Hey, this is Juan Tutors, and today we are working on the August 2024 Algebra 1 Regents. This is literally the second Regents ever that's working on the next generation learning standards. So I'm really excited about going through this Regents with you. My goal is to make the GOAT of all tutoring videos for you. So if you feel that this video is the GOAT, just let me know in the comments, say this video is the GOAT. I am going to go over what's said on the very first page, but I'm not going to read through it for you because I know that what you want to do is to go right into problem number one, numero uno. So I am going to do that. But the very first thing I'm going to do for part one, note that there are 24 questions in this part, and each question will receive 2 credits. That's going to be very important for when we do the math in terms of what to focus on in terms of getting the best grade possible, right? So the very second thing actually that I'm going to note that diagrams are not necessarily drawn to scale. When I tutor students, I actually have them cross out the words not necessarily, and I have them put the words almost, definitely. In fact, I don't recall any diagram that is even capable of being not drawn to scale in this test. That's a much more relevant comment in geometry and a little less relevant in Algebra 2 and way less relevant in Algebra 1. But it is an important thing to know that they tell you that diagrams are not necessarily drawn to scale. But the reason I have students cross that out is that when students read that, they assume that it means that diagrams are almost never drawn to scale and that scale can't be used, when in fact it's the opposite. Scale can almost always be used to solve problems successfully. So we'll talk about what it means to be drawn to scale and how to use it, if it comes up at all for us. But that said, we're going to hop right into number one, numero uno, and I have my notes right here. Number one, what is the correct factorization of x squared plus 4x minus 12? So one of the things that I want to do to make this truly the GOAT of all math tutoring videos is that I want to be able to get you to the point where you could solve the problem or eliminate some answers somehow. Sometimes I'll give you hints to eliminate some of the answers. Why? Because I want to give you as many strategies as possible. You're not going to be asked exactly these questions during the Regents. That is a common question in the comments, by the way. You're not going to be asked exactly these questions, but it is in Algebra 1 Regents. Like, there's a limit to how many different questions they can ask you. So we are going to go through some test taking strategies that help you maybe a little bit in some of these problems, but a lot in many problems. So this question, what is the correct factorization of x squared plus 4x minus 12? Is it x plus 3x minus 4? Or is it x minus 3, x plus 4? Or is it x plus 2, x minus 6? Or is it x minus 2, x plus 6? So one of the best strategies that I love to use is plugging in test values, okay? Test values, okay? And by the way, if you didn't notice already, this video is a vertical video. I wanted to do a few videos in vertical format to see if it is preferred by all of you. My goal again is to make the best video for you. I've been making my videos horizontal, but I want to see if you tell me if having the video vertical is better for you. You could go check out some of my horizontal videos after this and let me know. So, but one strategy for eliminating answers is plugging in test values. The easy values, well, what do they include? Well, 0, 1, -1, and then also roots, okay? And special value, other special values, okay? So what do I mean by other special values? Actually, I just mean a lot of things. That really should stay about as generic as that comment stays. Other special values. If you see something, some number that maybe is really easy to plug into the problem, use that. Or some number that you know is going to 100% give you the correct answer, then that's another special value, right? So the thing about the easy values, though, the easy values, they don't always eliminate all answers, all incorrect answers. But they do quickly eliminate some answers. And in this case, it happens to be if I plug in x equals 0, this is a rare situation because often plugging in x equals 0 is so quick that even before you have a really nice test value to plug in, I usually recommend plugging in x equals 0. I'm giving you that recommendation now, despite the fact that it doesn't help in this problem, because you're going to see that it's going to help in a ton of other problems. But if I plug in x equals 0, I get 0 plus 0 minus 12, right? 0 plus 4 times 0 minus 12, which is equal to negative 12. Now, if I plug in x equals 0, I get 3 times negative 4 is equal to negative 12. And unfortunately, I get negative 12 here, negative 12 here, and negative 12 here. So I don't get, it doesn't eliminate anything if I plug in x equals 0. But again, notice how quick I could plug in x equals 0. But it turns out that if I plug in 1 or negative 1 or a root or other special values, I could usually eliminate a lot of answers. And in fact, in this problem, a root is a very convenient number to plug in. A very, very convenient number to plug in. So, because it eliminates one answer at a time. So I would recommend plugging in a root. Now, the thing is, these all have 8 total roots in the answer choices, and then plugging into the original might be a little tougher. But guess what you have on your test? You have this massive, beautiful calculator, right? So I'm gonna use this calculator. Now I'm gonna get a view. Where's the view? Detached LCD, like a nice big LCD that I'm just gonna move around so you could see what I'm typing in nice and easy. So I'm gonna plug in right into the screen here, but I'm gonna show you other ways that you could plug in later. Again, I wanna give the GOAT of all tutoring videos. So this one I'm gonna plug in like the root x equals 3. Which is a root of choice 2. Oh, and by the way, I did use my random number generator. I always want to test. If I want to test, I want to test at least one of the choices to simulate what testing looks like. But at the same time, it is a waste of your time if I sit there and test every single answer choice when I could just tell you, go ahead and test every answer choice. So I'm going to test 3. I do the number 3 minus 3, parentheses, 3 plus 4, close parentheses, and I get the number 0. If I plug in x equals 3, the choice 2 equals 0. Let's see what the original equals. 3 squared plus 4 times 3 minus 12 equals 9, not equal to 0. So the fact is that when I plug in x equals 3, I get y equals 0, but here I get, so I'm going to call it f. I don't want to call it f of 3. Sorry. Let's see. Plug in 3. Plug in x equals 3. I get 3 squared plus 4 times 3 minus 12, which is equal to 9, not equal to 0. Right? Not equal. This is not equal to 9. So choice 2 is not the correct answer. By plugging in, I was able to successfully eliminate an answer. Now I got a 1 in 3 chance of getting it right. And now you might wonder, I just spent a little bit of time to do that. Is it worth my time to do that? And my answer to you is absolutely yes, because getting an answer completely right is 100% worth your time. Now, if I plug in x equals 3 into all the other answers, will the other answers tell me which answer is correct when I plug in x equals 3? I actually do think that the answer will pop out just plugging in x equals 3 into all of the answers. Okay? So my point is plugging in x equals 3 will give you the answer. And I do want to finish this test taking strategy because there are harder values. The harder values, I'm just going to put in the number 9 because the number 9 is just an easy one button press to plug in. The number 11, right? I'm going to put in the number like, I don't know, like 1.1, which is harder to type in, but almost always, because the test is so integer focused, despite the fact that they make you do fraction stuff and decimal stuff, it is so integer centered that plugging in a decimal almost always will give you the correct answer. So any weird value, okay? And the benefit of these is that they're harder to plug in, okay? Plug in, but will almost, and I should actually go here. It's all of this and all of that. So it will almost always give the correct answer in one step, in one test. Meaning, if I plug in x equals 1.1, for example, into all of these choices, the answer is going to pop out. Almost guaranteed. Almost guaranteed. I did say almost always. You might have gotten unlucky in general, and in this one, I know that 1.1 will give you the correct answer in one step. But in some, maybe you get unlucky. Maybe you just chose just the wrong number that you plugged it into all of them. So you confirmed. Remember, this is a testing method, guess and check. So if you get the correct answer for one of the choices, it doesn't mean that it's 100% correct. You still got to test the other ones if you're just guessing and checking. Okay. Now, the second thing that I'm going to do with all of these problems, because this is an algebra test, some answers, some problems lend themselves nicely to really good test taking strategies, just like this one. But this problem could easily be a part two on the test. Literally take off the multiple choice questions, and that is a part two question. What is the correct factorization of x squared plus 4x minus 12? Question mark. End of sentence. That's a number 25 or a number 26. Easily a number 25 or number 26 type question. So I do want to go over the algebra to make this the go to all tutoring videos. So how do I do this problem? Here's my answer, okay? I write x squared plus 4x minus 12. I write that, so a is equal to 1. I do have to check that a is equal to 1. B is equal to 4. And C equals negative 12. Okay, when a is equal to 1, that is a very convenient situation because I could just put blank plus blank equals b, which is equal to 4. And I could do blank times blank equals c, which is equal to negative 12. So I'm playing what some of you call the x game, but I don't write it as an x because I've noticed every single time I teach it, students mix up which one goes plus, which one goes times, and then I realized after a while that it's not me the way I teach it because when I tutor students, which means I never taught them, I tutor them from other schools. They struggle with the X game, but the moment I do it this way, problem solved. So blank plus blank equals B, and blank times blank equals C. So two numbers that add up to 4 and multiply to negative 12. I'm going to do the factor rainbow with negative 12. 1 and 12. 2 times 6. 3 times 4. Now, I need one of the numbers to be negative to multiply to negative 12, and I need the two numbers to add up to 4. If I do 6 times negative 2 is negative 12, and 6 plus negative 2 is 4. 6 plus negative 2 is 4, and 6 times negative 2 is negative 12. Perfect. Then I got my numbers, and immediately I can hop over to the factorization. X plus 6, x minus 2. And where's my answer? X plus 6, x minus 2. It is choice 4. Okay? There are other ways of eliminating answers, but I can't do every single test taking strategy for every single problem, but it could be, especially since I am going to talk about a lot of test taking strategies along this test. Okay, on that note, we go to number 2. Which statement can be modeled by a linear function? A printer can print one page every 3 seconds, or a bank account earns 0.5% interest each year, compounded annually, or the number of cells in an organism doubles every 4 days, or the attendance at a professional sports team games decreases by 1.5% each year. Okay, I would advise you to really put a lot of thought into this. And the thing that I didn't say for the first problem that I'm gonna say for this one, what is your best strategy for when you're watching this video on your own? If the test is like tomorrow, or the test is in a few hours, you may wonder, is it better for me to do the problems or listen to Juan do them? Well, if you're going to listen to me do them, go ahead and listen to me do them. But the best strategy, believe it or not, even if the test is in a few hours and you have to maybe not get to some of the questions because you tried them, it actually is better to try them choose an answer, stick to the answer. Don't say, I think the answer is this, and then move on. You could say, I think the answer is this, but you have to say to yourself, I am going to choose this one. Let's see what Juan did. But my advice to you is to use correct math to arrive at your final answer. Now, why am I saying choose your answer before you move on and watch me do it? Is because I've had students like say, "Oh, I think the answer is this one," and I'm like, "Oh, the answer is this one." It's like I knew it was that one. Actually, the answer is that one, or I knew it was this one. Like, and I literally hopping back and forth saying, "Oh, I knew it was that one. Oh, I should have picked that one. I knew it was that one. Oh, I should have." In the same question, swearing that they actually knew the answer because they picked two answers in their head and didn't even realize it. So you actually have to say, you have to commit to an answer so that you can, because when you do that, you also start exercising strategies that allow you to choose one answer over the other. Okay, now, how am I going to do this one? A linear function, what's the difference between a linear function and a, well, actually, let me actually do some process of elimination first because for every single problem I want to be able to eliminate some answers. I noticed that choice 2, a bank account earns 0.5% interest each year compounded annually. And number 4, the attendance at a professional sports team game decreases by 1.5% each year. They're asking which model can be modeled by a linear function. Number 2 and number 4 have the same model, the same type of model. So 2 and 4 have the same type of model. Now, suppose I don't know what kind of model this is. It is exponential, by the way. Exponential, or also known as geometric. Okay. So what's the benefit of knowing that they have the same type of model? There can't be two answers. They can't both be right. There can't be two correct answers. Therefore, they're both incorrect. Notice I don't even, like fake student me, doesn't even know what kind of model is number 2 and number 4. But I do know that they're the same model. One is a percent increase and the other one a percent decrease, but it's the same, it's got to get calculated the exact same way, meaning the same type of model. So that means that they both have to be wrong. Now I have what I call a passing problem, okay? A passing problem, which I'm going to shorten to PP. You're going to see me write passing problem or PP for a lot of problems. So what is a passing problem? Let's talk about that right now. By the way, the beginning of this video is going to be a lot more strategy focused. That's why the first part of the video, we talk a lot more strategy, and then we keep using the same strategies or expanding on other strategies as we go along. So what is a passing problem? You'll notice that on this test, you need 82 points to get 100. But you might wonder, what do you need to get 65, which is the first passing grade? You need 28 points. You need 28 points to pass the test. The multiple choice questions are each worth 2 points, which means you need 14 multiple choice questions to get to pass. You need 14 multiple choice questions and nothing else. Okay? And now, why do I call this a passing problem? 14 out of 28 is almost, no, I'm sorry, 14 out of 24. It's 24 multiple choice questions. 24 is almost 50%. Okay, now you might argue it's not 50%. Well, no, I didn't say it is 50%. I said it's almost 50%. And in fact, a passing problem is defined the same way for every single Regents because this math actually works for every single one. 14 out of 24 is 58%, really close to 50%. So meaning that if you get almost half the multiple choice questions right, or a little more, then you pass the test. And so if you use test taking strategies, plus combined with doing some of the problems that you know how to do, it's a guarantee almost that you could pass this test if you can get every single question or almost every single question to a point where you've got a 50% chance of getting it right. Notice that number one, without knowing how to do it, by plugging in numbers, we actually got it to a 100% chance of getting it right. Plugging in a number, 3, eliminated choice 2. Turns out if you plug in 3 to all of them, it would lead you to choice 4. But we don't know that initially. Maybe two of the choices was going to be equal to 9 when plugging in x equals 3. So then you choose just a different test value. 100% chance of getting that one right, 100% chance of getting a few other ones right, and 50% chance of getting a bunch, almost all of them right. You pass the test. Sweet, right? So that piece of advice boosted your score by maybe 10 points. So now we are at the point where we don't know if it's either choice 1 or choice 3. Choice 1, which one is modeled by a linear function? Choice 1 is that a printer can print one page every 3 seconds. And choice 3 is that the number of cells in an organism doubles every 4 days. So the way I did it was I actually just created the model. So I did choice 1 and choice 3. Okay, choice 1, I'm going to do x, and then well, I'm going to do time actually and then number of pages printed. Okay, so after 3 seconds, 1 page is printed. After 6 seconds, a second page is printed. After 9 seconds, a third page is printed. 12 seconds, 4, 15, 5. Okay. Now, the third choice says the number of cells in an organism doubles every 4 days. So I'm going to do time and the population. P for population now. Okay. And I'm going to do I'm going to start with 4 days. And suppose that there is 2 cells. So well, at 0 days, suppose that there's just 1 cell. At 4 days, double 2 cells. Remember to double, 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 not adding one. So 4 more days, 8 days, double the 2, I get 4. 12 days, I got 8. 16 days, I got 8 times 2 is 16. 20 days, 16 times 2 is 32. And 24 days, 32 times 2 is 64. Okay? Now, I know what a linear function looks like. If I add a constant amount on the what you usually call the y-coordinate, right? Or in this case, the p-coordinate, while I'm also adding a constant amount, not 1 plus 3, adding a constant amount to t, this is linear. And in fact, this goes p is equal to t divided by 3. That is the function that is describing this printer situation. Whereas this one, if I add 4, right, plus 4. On this side, I'm multiplying by 2. So this is definitely exponential, also known as geometric, times 2, times 2, times 2. And so this one is described by p is equal to, in this case, 1 times 2 to the power. Now this one might be tough because now for t equals 4, I got to have an exponent of 1. For t equals 8, I got to have an exponent of 2. For t equals 12, I got to have an exponent of 3. So if I divide the time by 4, t over 4, then I have the correct exponent. 0 over 4 is 0. 2 to the 0 is 1. 1 times 1 is 1. Good. And then for t equals, let's say, 20. 20 divided by 4 is 5. 2 to the 5th is 32. 32 times 1 is 32. And so this is exponential, also known as geometric. Okay? Okay, again, linear, aka aka arithmetic, and this is exponential, aka geometric. Okay. Now, so by the way, we just verified again the choice is the answer is choice one. Okay. Número tres, number three. Which expression is equivalent to 3 parentheses x squared minus 2x plus 3 minus parentheses 4x squared plus 3x minus 1? Is it negative x squared plus x plus 2, or negative x squared plus minus 8x plus 7, or negative x squared minus 3x plus 8, or negative x squared minus 9x plus 10? And do you remember how I said that plugging in an easy value like 0, sometimes doesn't help at all with like number one, which is rare, by the way. It's been a while since I've seen a problem where plugging in 0 didn't help at all. But do you remember how I also said that sometimes plugging in 0 is just tremendously helpful? Notice for all of these choices, if I plug in x equals 0, I get 2, 0 plus 0 plus 2. I get 0 plus 0 plus 7. I get, when x equals 0, I get 0 plus 0 plus 8. And 0 plus 0 plus 10. So all of these are different when I plug in x equals 0. All of them are different when I plug in x equals 0, which means if I plug in x equals 0 into the original, I got the answer. So I'm going to plug in x equals 0 into the original expression. So what do I get? I get 3 times 0 squared minus 2 times 0 plus 3 minus 4 minus parentheses 4 times 0 squared plus 3 times 0 minus 1. And so I get 3 times 3 minus negative 1. And at this point, I can definitely eliminate some answers because they don't make sense. This one and this one. Even if I struggle with my arithmetic, these numbers can't give me a 2 or a 7. Maybe it gives me an 8 or a 10, and at this point I would say plug it into your calculator. Now, why, you might be wondering, why am I not finishing the problem for you? But I'm going to do the arithmetic for you after. But why am I not doing it right now? Because sometimes what students just want the answer and they just want to move on instead of learning how to do the problem, which is the thing that matters for you when you get to the Regents, or for those of you who are watching the GED, for the GED, when you get to the GED. Also, the other thing is that, like I said, the part twos literally look like part one questions with just the multiple choices crossed out. Like if I just said in a part two, number 26, let's say, which expression is equivalent to 3 parentheses x squared minus 2x plus 3, close parentheses, minus open parentheses, 4x squared plus 3x minus 1, close parentheses, question mark. And I didn't give any multiple choice. That is a part two. That's a part two question. In fact, it could also be part of a part three question, or even a part of a part four question. So we do need to know how to do this. And I'm going to talk about why it's really important to treat the part twos just as seriously as you treat the part ones in a moment. And also to treat the part ones just as seriously as you treat the part twos. You may be swearing to yourself that you're treating the part ones as the most important thing and ignoring the part twos. Chances are that if you're doing that, you're not even respecting the part ones. And that's why you struggle to pass. Notice that I'm showing work on every single problem so far, and that's relevant. We're going to talk about that too. But how do I do this problem? I'm going to do it manually. 3 parentheses x squared minus 2x plus 3, close parentheses, minus 4x squared plus 3x minus 1. Now, what I could do, I could put a 1 in front of here. I could put a 1 in front of here so I could distribute it. So I could distribute the 3 here. And just like I distribute the 3, I could distribute the minus 1. Okay? Notice I'm distributing a minus 1, which is going to be a sign changer, but I'm also here distributing a plus 3, which is not a sign changer. So I get equal to 3x squared minus 6x plus 9. Now the minus 1 is going to be a sign changer, minus 4x squared minus 3x minus negative or plus 1. And now I combine terms. I combine like terms. So I got 3x squared minus 4x squared. This is going to be an important thing. I do want you to know how to do arithmetic with negative numbers. Okay. But I also want to say your calculator is your friend. Uh, Using your calculator is not cheating. Your teacher might have been one of those teachers that trained you not to use your calculator, and I don't necessarily agree with that because this is not an arithmetic test. This is an algebra test. And a lot of teachers say, well, you can't know algebra without arithmetic, and that's actually false. Just false. So got negative 1x squared. And now minus 6 minus 3, same thing. If you don't know what minus 6 minus 3 is, predict but verify. I might think that minus 6 minus 3 is minus 9. Let's check that. Negative 6 minus 3 is in fact negative 9. So negative 6x minus 3x is minus 9x. And then plus 9 plus 1 is plus 10. And there is our answer. But before I do that, I just want to make sure that we do the arithmetic. I said 3 times 3 minus negative 1. 3 times 3 is 9. Minus negative 1. Minus a negative is the same thing as plus 1. So minus negative is the same thing as plus. So minus negative 1 is plus 1. And 9 plus 1 is 10. Okay? So that is why plugging in would have given us the answer just in one step. And we learned how to do it algebraically. Okay. Let's look at number 4, numero cuatro. At Adeline's first, shout out to Adeline, by the way, one of my students. At Adeline's first birthday party, each guest brought $1 in coins for her piggy bank. Guests brought nickels, dimes, and quarters for a total of $28. There were twice as many dimes as nickels and 12 more quarters than nickels. Which equation could be used to determine the number of nickels, x, that her guests brought to the party? Is it 0.05x plus 0.10x, 10x plus 0.25x equals 28? Or 0.05x plus 0.10 times 2x plus 0.25 times x plus 12 equals 28? Or 0.05 times 2x plus 0.10x plus 0.25 times x plus 12 equals 28? Or 0.05 times x plus 12 plus 0.10 times 2x plus 0.25 times x equals 28. So one of these answers is the one that makes the most sense. What are these numbers? To even understand how to do this question, we got to kind of know what these numbers are. So the equals, they're all equal 28. So we might say, what does that 28 represent? According to this, the total 20, they brought nickels, dimes, and quarters for a total of $28. Okay. 28 is equal to the total money brought. Okay, which means that the left side, being that that's an equal sign, the left side has to also equal the total amount of money brought. So that's what the 28 means on all the lines, right? Which means for all the lines. Let me erase this arrow because the 28 means that for every single line. So, well, what does that imply? If you look at equation 1, 0.05x plus 0.10x plus 0.25x is 28. They said that x is the number of nickels, right? X is the number of nickels. So that's another piece of information that's important. And oh, by the way, another thing that I will tell you is that a lot of students try to do the problem by crossing out irrelevant information. And here's the piece of advice that I'll give you. And a wag of my finger to not fourth grade teachers, because fourth grade teachers are doing a phenomenal job, but the actually elementary school curriculum where we're actually training students to believe that every single problem has irrelevant information. The only relevant information is things like, well, one problem we might be buying cantaloupes or cats or cars or castles. And it doesn't matter what we're buying. The thing that we're buying doesn't matter unless we're buying two different things. Then we got to take that into account. But the truth is that the thing that matters is that we're buying something. Virtually every problem, really every single bit of information matters. In fact, I think in my entire time doing Regents tests, I think I saw one problem with a piece of information that wasn't truly relevant. And then I've seen two other problems that had a piece of information that wasn't necessarily for the problem, but did allow solutions that used that piece of information, which is why that piece of information was there. And every single other problem, meaning we're talking about thousands, plural, thousands, maybe 6 or 7 thousand problems. Um, Maybe more actually, now that I'm thinking about it, because I'm talking about earth science, living environment, chemistry, physics. That's actually about 500 problems um, per 500 problems per season times 3 seasons, 1,500 problems per year, ish, uh, times 15 years of my career. We're talking about nearly 100,000 problems, and it might be more. So, and in all that time, I've seen one problem that had one piece of information that wasn't relevant, and then 2 problems where like one piece of information wasn't necessary, but could be used in a potential solution. And then every single other problem had every single bit of information necessary. Why am I mentioning that? Sometimes when you're stuck in a problem, go back and read the problem. Make sure you didn't skip any piece of information. The entire problem is relevant. Okay, so why am I mentioning that? If x is the number of nickels, choice 1 says 0.05x plus 0.10x plus 0.25x, never used information about the number of dimes and quarters. Not a single time did it use the information about the number of dimes and quarters. So this is wrong. Again, I'm going to cross it on red so I could write it in red. Number 1 did not use info about dimes and quarters. How much? How much are the dimes and the quarters worth? That problem says nothing about it. And of course, we need to know how information about the number of dimes and quarters because they have different values than nickels. So, another one, another piece of information that actually, and this is the beautiful part, it's that sometimes without knowing how to do the problem completely, some other piece of information sometimes eliminates all the incorrect answers. Like here, x is the number of nickels. So x is equal to the number of nickels. And then 0.05, remember that 0.05. So this is something that you do need to know. They assume that you know it is equal to the value of a nickel. 0.10 is equal to the value of a dime. And then 0.25 is equal to the value of a quarter. Okay, so I had to pause for a second just to make sure I was okay. So x is the number of nickels, right? So if 0.05 is the value of the nickels, then 0.05x is equal to the value of all the nickels brought. Notice that choice 2 has that information. Choice 3 actually has the wrong bit of information multiplied by 0.05. And choice 4 also has the wrong piece of information multiplied by 0.05. So choice 3 and choice 4 are wrong. And at least it seems that our math is just that. Before we even created the equation, our math seems to be implying that choice 2 is the answer. So without with all that crazy information, we eliminated one of the choices because it didn't make sense for the problem at all. And then 2 other pieces of information, a different set of information, eliminated 2 other choices, and then we're left with the only possibly correct choice. So now, how did these other ones get generated though? How did choice 2 get generated? The value, so 0.10 times the number of dimes is equal to the value of all the dimes. Remember, the value of 1 dime is 0.10, so 0.10 times the number of dimes is the value of all the dimes brought. And what is the number of all the dimes? Twice as many dimes as nickels. Right there, twice as many dimes as nickels. That's 2 times the number of nickels, okay? Which is 2 times x, or 2x, okay? So 10.10 parentheses 2x is the value of all the dimes, okay? And then finally, We're going to do the same exact math for the number of quarters, just so that we're sure about what we're doing here. 0.25 times the number of quarters is equal to the value of all the quarters brought. And they just said it here, 12 more quarters than nickels. So the number of quarters is equal to 12 more than the number of nickels. Notice that I wrote that in words. I actually recommend to students to write a word equation first and then convert that into an algebraic equation. So this is equal to x plus 12. Or just without the parentheses, x plus 12. Okay? So 0.25 parentheses x plus 12. And so then if you put the value of all of the money together, so the value of all the money equals the value of the nickels plus the value of dimes plus the value of quarters. Which, again, I'm going to add all these numbers up. So the value of the nickels, 0.05 x, that point is really high up there, 0.05x, plus the value of the dimes, 0.10 times 2x, plus the value of the quarters, 0.25 times x plus 12. And that's equal to the total value of the money brought, which was 28. And there is choice 2. So our suspected answer, based on just process of elimination. By the way, process of elimination, which we did correctly eliminate choice 1 and correctly eliminated choice 2 and 3 rather, and correctly eliminated choice 4. It's not that we were doubting the answer. We did correct process of elimination to do that problem. And at some point, when the problem lends itself to some notation, I'm going to teach you what I do to mark when a problem I think is correct versus when an answer I know, I'm sorry, when an answer I think is correct versus when I know an answer is correct. And also when I think an answer is incorrect versus when I know an answer is incorrect. Slightly different notation. You could borrow my notation. It's really easy to remember, really easy to adopt, no matter what your muscle memory is. So that's why I recommend it. Okay? Numerical number 5. A student creates a 4th degree trinomial with a leading coefficient of 2 and a constant value of 5. The trinomial could be 2x to the 4th plus 3x squared plus 5, or 2x to the 4th plus 5x plus 3, or 4x squared minus 3x plus 5, or 4x cubed minus 5x squared plus 3. Now, this is when I strongly suggest going through the answers and going through the problem, reading the entire thing, and seeing if you could eliminate all the incorrect answers. Because the way to do this problem, even if you do it by constructing the problem, you could also just as easily, in this case, do this problem by eliminating all the incorrect answers. So that's what I'm going to do. I'm not going to pause the video and let you try it. I did that for a video, and it made the video entirely too long. So you, with the power of YouTube, literally have a pause button. So pause the video and see if you could get the answer right. That said, on my side, suppose that there's a piece of the information that I'm just not 100% sure, but the piece of information that I am most sure of is like this: the constant value of 5. Now, in your case, the part of the problem that you're most sure of might be something else, right? You might be more sure of what the 4th degree trinomial means, or you might be more sure of what the leading coefficient of 2 means, but I happen to be more sure of, my fake student me is more sure of what constant value of 5 means. By the way, what do I mean by fake student me versus real tutor me? Real tutor me is Juan. I am the founder and president of JuanTutors.com. That is real tutor me, giving you advice, being me. Fake student me, sometimes I have to tell you what I would do if I was a struggling student. So that's when you hear me say fake student me, I mean what I would do if I was a struggling student or a student with the normal amount of understanding that an Algebra 1 student has. So fake student me might not be sure about the entirety of the words here, but I happen to know the constant coefficient is the number at the end of the polynomial without a variable multiplied to it, which means I know that this one has a constant multiple of 5, a constant value of 5. This one has a constant value of 5. This one definitely has a constant value of 3, so makes that 100% incorrect. And this one has a constant value of 3, making it 100% incorrect. Notice that choice 2 and choice 4, I crossed it out at the answer choice. Okay? I crossed out choice 2 and choice 4 at the 2 and at the 4. I haven't done anything about choice 1 and choice 3 yet. But then I go back into the problem and I read, oh, student creates a 4th degree trinomial with a leading coefficient of 2 and a constant value of 5. The trinomial could be, now I got the constant value already. Now, fake student me might be saying 4th degree trinomial. I think this is the exponent. Now, I don't have to write this. This is the exponent. Fake student me would probably just write the word exponent, question mark. 4th degree trinomial, okay? Then I say, fake student me says, wait, I think I actually know what the leading coefficient is. This is the coefficient of the leading term in standard form. So now in process, I think this is the exponent means that I think that this one is correct. Notice I put the checkbox there, and I think this one's incorrect, so I put a checkbox on top of it or next to it. That's my notation for when I think an answer is correct. So I think this is incorrect. Incorrect. My handwriting is not the best. Believe it or not, I am, and I have been working on the handwriting. But unfortunately, it's gotten worse over time. That's just the nature of it. Which is weird, but whatever. This is what I know. Sometimes my letters get twisted. Maybe there's a little what is it called? Dyslexia. Maybe there's a little dyslexia in there. Anyway, so I put an X next to the answer if I think it's incorrect. I put an X on the answer if I know it's incorrect. Okay? So at this point, fake student me might be debating what to do about this problem because maybe fake student me can't figure it out. At this point, though, the most logical choice to make is choice 1 because I, for good reasons, think choice 3 is incorrect. And for good reasons, I think choice 1 is correct. So I may have to choose choice 1 and move on. Luckily, notice what happens. I technically have a passing problem because I have a 50-50 chance of getting it right if I just did a wild guess. But in reality, I use correct math to make sure that it's actually more logical to choose choice 1. So I actually have a way more than 50% chance of getting it right. And in fact, choice 1 is the correct answer. So the leading coefficient, this is actually correct. This is the coefficient of the leading term in standard form, and this happened to be correct. The 4th degree is the exponent, the leading exponent. So this is correct. So creates a 4th degree trinomial. I have an x to the 4th with a leading coefficient of 2 plus and a constant value of 5 plus 5, and now the trinomial has some other term that doesn't change the properties that they defined, and choice 1 satisfies all of those properties. Yeah. Notice that you technically got a passing problem that wasn't even a passing problem. It was a 100% correct problem. A passing problem is what I call a problem that you get down to 50-50 chance of getting it right, meaning you've eliminated 2 answers. A fully correct problem, you just got it right. Choice one, remember, choice one, we didn't even know how to do it, supposedly. We could just plug in. Well, we did know how to do it, and we did do it, but we could have just gotten it by plugging in, and that's what actually we did, right? Numero 6, number 6. When solving the equation 4x squared minus 16 equals 0, Laura, shout outs to Laura, one of my great friends at work, Laura wrote 4x squared equals 16 as her first step. Which property justifies Laura's first step? Is it the distributive property of multiplication over addition, or the multiplication property of equality, or the commutative property of addition, or the addition property of equality? So let's make sure we know what she did, at least write it one step at a time. 4x squared minus 16 equals 0. And then she did something, and then she got 4x squared equals 16. So what did she do to go from 4x squared minus 16 equals 0 to 4x squared equals 16? That matters. This is the only way to do this problem, by the way, I think. Write it whatever format you want. By the way, not every teacher requires you to write how you got to each step. Many teachers ask you to show your work at the beginning, but at some point had to make concessions because students refuse. This is one of the things that I will give you as advice for tomorrow, for whenever your test is, but also for the rest of your life. Let your teacher win the battle if your teacher says to show all work. They're actually right about that. I know that some teachers maybe ask you to do things that maybe don't seem logical to you, but showing work is not one of those. Showing work actually fixes an immense number of just logical cognitive dissonance. And when I tutor, I'm just constantly fixing cognitive dissonance. That's why I've had students who are like getting 60, 62, 63, and their parents are just like, I just want them to get a 65. And I tutor them 1 or 2 3 times, and they get like a 97 because I fixed the cognitive dissonance. But one of the things that does it is having them show work. And then because they have been, by choice, avoiding work the whole year, I have to show them what showing work looks like. So one of the things that well, how do I get from 4x squared minus 16 equals 0 to 4x squared equals 16? I just add 16 to both sides. Okay? So now that I see what it is that she did, now I go to the answers. Now, suppose I didn't know that. I do remember, though, that the distributive property of multiplication over addition, this is like the one where it's like 4, um, let's say 3 parentheses x minus 5 is, I could distribute the 3 equals 3x minus not 5, but 15. That's the distributive property. Okay? That doesn't happen here. So even if I didn't know what happened, nothing close to that happens. So I know that that one is incorrect. But now fake student me knows that choice one is wrong. Now I have to choose between multiplication property of equality or commutative property of addition or addition property of equality. In this case, I didn't do any multiplication, so I suspect strongly fake student me is just lacking so much self-confidence so that even though I know I didn't do any multiplication, I just feel like maybe I could be wrong. But I think that choice two is wrong just because choice one says multiplication property of equality and choice two rather says multiplication property of equality and choice four says addition property of equality. Like if it's going to be any of those, it's probably going to be number 4 between 2 and 4, right? I didn't do any multiplication. So notice though, I crossed out number 1 at choice 1 because I know it's incorrect. Fake student me thinks choice 2 is wrong, so I put an X next to it. But either way, this isn't technically a passing problem because I think choice 2 is incorrect as opposed to knowing choice 2 is incorrect. But if I happen to know choice 2 is incorrect, then that's a passing problem because I got 50% chance of getting it right. So it's either commutative property of addition or addition property of equality. Okay? So let's talk about what these are. The multiplication property of equality says you can multiply both sides of an equation by a number. It's legal. That's what it says. Okay? So, but did I multiply both sides of the equation by a number? I did not. Okay? The commutative property of addition says that you could change the order of addition, again, with a special note, only if I only change the addition. Change the addition. If you find that by changing the addition, you actually change something else too, maybe by changing the addition, you change the multiplication too. That's just not even legal. If you find that by changing the addition, you change the subtraction too, that's not legal. So you only change the order of addition. So 5 plus 3 is equal to 3 plus 5. 5 plus 3 equals 3 plus 5. Okay? Or x plus 6 equals 6 plus x, that kind of thing. That didn't happen here. I didn't change the order of an addition. I added to both sides of the equation. And so what is the addition property of equality? I can add any number to both sides of an equation. And in this case, I added 16 to both sides of the equation. So that's actually what I did. Added 16 to both sides of the equation. EQN for me is shorthand for equation. So that's what I did. So choice 4 is the correct answer. Okay. All right. Número 7, number 7. Which expression results in an irrational number? Irrational number. Is it radical 3 times radical 3, or negative 2/3 plus a quarter, or 5 times radical 81, or 1/3 plus radical 3? So 99.9 more percent of the time, the calculator will tell you what the correct answer to this question is. And I'm going to show you how to do that. I told you that I would do plug into, if I'm going to plug into any answer at all, I'm guaranteed to plug into choice 2. I need an irrational number. So, what just happened there? What is an irrational number? Sorry, my screen is flashing. Is your screen flashing? No, so that doesn't matter. Okay, so what is an irrational number? An irrational number cannot be written as a ratio of two integers. In fact, that's where the word rational comes from. So rational number can be written as a ratio of two integers. Notice I said can be. I didn't say is, I said can be. There are plenty of rational numbers that aren't at the moment written as a ratio of two integers, but you can write it as a ratio of two integers. And if you can, it is rational. So I told you that I was going to do choice 2. So I'm going to do parentheses, negative 2 over 3. Yes, in many cases when you're doing fractions, you do need parentheses. So I used parentheses. Why do you need parentheses, by the way? The horizontal fraction bar is a grouping symbol and the diagonal fraction bar is not. So how do you group without the horizontal fraction bar? You use parentheses. Some of you, clever among you, actually know how to put fractions into the calculator. And maybe if I'm feeling nice, I'll show you how to do that by pressing somewhere in the math button. But you got to find it somewhere in the problem. So negative 2/3 plus parentheses 1/4. Close parentheses. And now if I do this, I notice that this is not written as a ratio of two integers. How do I convert this into a ratio of two integers? If possible, I press the math button, arrow frac, and that converts it into a ratio of two integers, and that's negative 5/12. Okay? I did promise you that I would show you how to do this problem by hand. So I'm just going to show you. So anyway, so the point is irrational. This is rational. So we've confirmed that choice 2 is incorrect. Okay? Now, If you actually just do the arithmetic for choice 1 and choice 3, you might find that these are identical in structure. Therefore, since this problem can't have two answers, choice 1 and choice 3 can't be both right, and because they have the same structure, they both have to be wrong. Radical 3 times radical 3 is equal to 3. Radical 5 times radical 81, this is equal to 5 times radical 81 is 9, which is equal to 45. Even if I didn't know how to write this as a ratio of two integers, they're both integers. They can't both be right. So if I wanted to say, oh, an integer is not rational, well, then choice 1 and choice 3 would be irrational. That has to be wrong. Well, how can I possibly write 3 as a fraction? 3 is equal to 3 over 1. There's a ratio of two integers. 45 is also equal to 45 over 1. And if you think that's cheating, which, by the way, it's not, right? Because it is a ratio of two integers, it's just easy. But if you wanted to write it in a more difficult way, sure. How about 6 over 2? There you go. Now it's a ratio of two integers where the denominator is not an easy one. So choice 1 and choice 3, being that they're identical in structure, they're both integers, can't both be right. Therefore, they both have to be wrong, leaving choice 4 as the only answer. And there's a theorem. The sum of two rational numbers is rational. How do I know that? Well, negative 2/3 plus 1/4. I can get a common denominator, and that's how I know. I do times 4 here. Oops, I wanted to get a different color. Times 4 here. Times 4. Times 3. Times 3. And I'm doing this manually because, yes, they don't really require you to do this with arithmetic. But you're going to have to know how to do this with algebra in part 2s and 1s and 3s and 4s. So we do it with arithmetic now. And so we got negative 8 over 12 plus 3 over 12. And we can combine the fractions now that they have common denominators. 12 and minus 8 plus 3. And I can use my calculator if I wanted to predict but verify what minus 8 plus 3 is. Minus 8 plus 3 is, I'm not going to simulate it every time, but normally I would simulate, if I was tutoring you, by plugging in negative 8 plus 3, I would say, I think it's actually negative 5. I would plug it into the calculator, and actually it turns out that I'm right, negative 5. And so the negative 5 over 12 is the value of choice 2. And in fact, every rational number plus every other rational number can be combined by exactly that method, getting common denominators and then combining them by combining the numerators and keeping the denominators. Okay? And then there's a second theorem, is the sum of a rational number and irrational number. One rational number plus one irrational number is irrational. Okay? And I'm going to say this sum or product. And here, actually, a sum or product. And then here, just for clarity, I'm going to put non-zero. Non-zero rational number. Now that's correct. Because if I add, well, it's still correct for a sum, but if I don't put non-zero, then it becomes false, because if I multiply by 0, the product is 0. 0 is rational, 0 over 1 or 0 over 2, whichever you prefer. Okay? Now, here's the kicker. You might say the sum or product of two irrational numbers you might just assume that it's one thing or the other. You might assume it's rational. You might assume that it's irrational. But if you're actually working with two rational numbers, it might be one or the other. Might be rational or irrational. To prove that it could be irrational, radical 2, which is irrational, times radical 3, which is irrational. Radical 2 times radical 3 is radical 6, right? That's irrational. But if I do like choice 1, Radical 3 times radical 3 is equal to 3. This is irrational, and this is rational. So the way to do this problem, you actually have to manually do the problem. You can't just guess that the answer is choice 4. Although if you knew the theorem that a sum of a rational number and an irrational number is irrational, then you could just state that choice 4 is the answer. But in other problems, you may have to just go through the arithmetic. Okay? Oh, before we go to number 8, let's talk about snacks. And this is actually an important question. Now, if you don't want to hear about snacks during the test, uh, you can go ahead and skip this part, but actually this is a more important part than you think. There's a lot of things that students do to prep for a test that actually are very bad ideas. Like, for example, students who never drink coffee, then deciding that they're going to bring a nice cup of coffee and maybe put like a double shot of espresso in the coffee and go into the test that way. That is very likely a mistake. So if you are a professional coffee drinker like I am, then go ahead and bring your coffee. Okay. I'm not gonna say don't. I'm not one of those teachers that say, "Oh my God, coffee technically it's a drug," and it is a drug, but it's a legal drug, and they let kids buy it, they let adults buy it. So if you are a professional coffee drinker, then go ahead and bring coffee. If you're not a professional coffee drinker like me, do not go ahead and buy a double shot of espresso coffee like something insane like that, because what's going to end up happening is that you're going to go into the test and you might find that you actually get an unreasonable amount of hunger in the middle of the test. People who drink coffee, professional coffee drinkers like me, often say that when I drink coffee, I get full. So how could you say that when someone drinks coffee, they're going to get hungry? The problem is the way our bodies react after a professional amount of drinking. It's not that the coffee makes us full. It's actually not that the coffee makes us full. The coffee eventually causes us to crave carbs to a level that we don't recognize that actually occurs, because when we go to eat lunch, suddenly our lunch is maybe a little bit more unhealthy than we normally think it would be. Maybe, oh, but I ate a salad, but did I use a whole bunch of dressing? Or did I have a sandwich? Or did I eat way more than I expected? A lot of people who drink coffee uh, end up having very unhealthy meals right after. And on days that they don't drink coffee, suddenly they want a salad or something healthy, and they're surprised on a weird day that they didn't drink coffee, but it's actually not a coincidence. Coffee makes you hungry. So if you don't drink coffee professionally, don't get a strong coffee or a regular caffeinated coffee. However, I'm not going to say don't get anything like a coffee at all. Actually, believe it or not, if you just bring a decaf coffee is not caffeine free. You would think decaf is caffeine free because of the name. No, decaf means that a bunch of caffeine was removed. The vast majority of the caffeine was removed. But if you're not a professional coffee drinker, that tiny amount of caffeine that is in a decaf coffee is actually helpful. Now, the second thing is if you put milk in your coffee, I actually recommend putting lactose free milk in your coffee. Um, if you prefer oat milk, sure. If you're lactose intolerant, I don't not recommend milk, but I recommend like lactose free milk. Or if you have a lactate pill, throw that in there. Or if you could take a lactate pill with your coffee, sure. Because what you don't want is your stomach to get bubbly in the middle of a test, right? Let's be honest. A second snack that I recommend is Fairlife protein shake, which I'm going to be drinking very soon. Okay. Now I'm not sponsored by them, although if they want to give me a call, please do. The thing I like about this one is it's only got 2.5 grams of fats and it's only got 4 grams of carbs and it's got 30 grams of protein. Now, I'm not one to say that a small amount of fats and small amount of carbs is bad for you, maybe like 10 or 12. Uh, like, so if this was whole milk with a little bit of sugar, I actually would be okay with that for a Regents. If you're taking it as a health food snack, that's a different story. But if you're going for a Regents, a little bit of sugar or fats is not a bad thing. It gives you a little bit of energy. This doesn't have much energy. So if you're taking this for energy, not the best. But if you're taking this to stave off hunger, this is phenomenal. And that it does. And plus, it's a liquid, so it hydrates you. Okay? The last snack that I'm going to recommend, and again, not sponsored, but if they want to give me a call, they absolutely can. This is not going to focus because it doesn't focus automatically. But this is a pure protein bar. Pure protein bar, again, because it has 20 grams of protein, it'll stave off the hunger. And this one does have 5 grams of fat and 18 grams of carbs. Notice that's a lot more carbs than the Fairlife milk. Okay. Again, but during a Regents, I'm not an enemy of the amount of carbs that this has. But what this does, it staves off the hunger. And because of the ingredients, it doesn't cause your stomach to get bubbly or cause you to have to use the bathroom with extreme urgency and cause you to lose time that you could have been using taking the Regents. Instead, having something like this, pure protein bar, Fairlife milk, and a coffee decaf if you're not a professional coffee drinker, or regular if you are a professional coffee drinker, but with lactose-free milk are things that I recommend. The last thing that I'm going to recommend, any meds that you normally take, go ahead and bring those with you. Do not take medical supplements that are not prescribed to you because, and I've seen this happen, where students take these supplements that are supposedly illegal aids, but then they get to a point that they're focusing so much on the test, they're focusing literally on like the font quality and the print quality, the texture of the paper itself, more than they're focusing on the actual test. Okay? Don't take anything illegal, but anything that is prescribed to you, you could take. Definitely, if you have a Weezer squeezer like I do, I've taken the Weezer squeezer in the middle of a video. I don't have any shame in taking my Weezer squeezer at any point. But bring it with you. Make sure that you have it accessible, so that if you do get a little bit tight, you could take and have a bit of a nice breather. Take it without looking at the test, so that you could actually even use that as a break. Speaking of breaks, like if you do need a break, like looking away from the test and shaking your head a little bit, not like vigorously so that you're jostling your brain and giving yourself a headache, but looking away and just shaking your head a little bit actually clears your head. It's a thing. It's a thing, a psychological thing. Looking away and clear and shaking your head a little bit is a thing. If you've ever been in an argument with somebody and they don't like the thing that you said, sometimes you'll see them look away and shake their head. Uh, because they don't want to hear the thing. Or you may have done it yourself when your parents are right about something that you don't want to hear, right? Or your teacher's right about something that you don't want to hear. You look away and you shake your head because you don't want to hear it, because it clears your head. And it clears your working memory so that you could do better on the next problem. It's actually not a bad strategy. On that point, we are going to move on, and I'll talk about subscribing. Only subscribe if you feel that I deserve it. Only subscribe if you think that this video has helped. As you see, well, let me talk about it later because I know you guys are itching to get to numero ocho number 8. So numero ocho number 8, which equation has the same solution as x squared plus 6x minus 18 equals 0? Is it x plus 3 squared equals 24? Or x plus 3 squared equals 27? Or x plus 6 squared equals 24? Or x plus 6 squared equals 27? Now, unfortunately, this one, it doesn't lend itself quite as strongly to just plugging in a number and guessing. Okay? But what can we do to get this question right? And again, the subscribe is only if you feel like the video has helped you. So I'm going to get the calculator out, okay? And I'm going to show you another way that you could plug in numbers. For all the problems that we did earlier, another way that you could plug in numbers that we're going to use on this problem. We're going to press the y equals button. And now we're going to actually clear these things. Now, you might say, why didn't I clear this before the video? But those of you who have seen a bunch of my videos may have seen me clear exactly these problems during the test. For some reason, this software, every time it resets at some point to some point in the past, as opposed to resetting completely. I don't know why. Those problems that you saw me clear, I think I typed those in like maybe late 2023. So that's why I had to clear exactly those problems. Anyway, so what I'm going to do, I'm going to plug in x squared plus 6x minus 18 equals 0. X squared plus 6x minus 18 equals 0. And I can't plug in equals 0, but equals 0 is the x-axis, right? And I'm going to plug in. Now, I said that I'm always going to plug in choice 2 because that's what my random number generator chose for me to plug in, so that I don't unbiasedly accidentally choose always an answer that I know is incorrect, or vice versa, choose one that I know is always correct. So I'm going to start with choosing choice 2. Now, which one should you choose? You should probably choose the one that you think is correct. Or if you don't know at all which one's correct, you should choose choice 1, and then choice 2, and then choice 3, and then choice 4. Okay? And then the second one I'm going to plug in is x plus 3 squared equals 27. How do I plug that in? I'm going to do x plus 3 squared. And the second thing I'm going to plug in is so I'm actually going to, let me show you how I would do this. I would subtract 27, and I get x plus 3 squared minus 27 equals 0. So let me actually do it that way. There's so many different ways that you could plug it in using the y equals function. I just last minute chose a different way than I started. So x plus 3 squared minus 27. Maybe this one's right. Okay. And if this one's not right, the good thing is that I could change this to choice 1 by just replacing the 7 with a 4. Or I could change it to choice 4 by replacing this plus 3 with a plus 6. Or I could replace it with choice 3 by replacing the 27 with the 24 and the plus 3 with a plus 6. So you might think that doing all of this work is very time wasting, but it's actually not, because the moment I try one of them, it's really easy to modify it to test the other ones. Okay? So now what do? I graph them. Okay? I gotta do graph them. I'm gonna do zoom. Actually, I do zoom and do zoom standard, choice 6. Okay. Now these have to have the same exact solutions, which means they have to cross the x-axis at exactly the same place. Let's see. They actually not only cross at exactly the same place, they literally have the same graph. Let's go to the table. Actually, I'm going to go to table set, make sure that I'm on auto. That allows me to scroll. And they seem to be identical. So in this case, I got lucky that they're actually identical. So that tells me immediately that that's the correct answer. Again, what I did table set in blue. So I pressed the blue second button and press table set, change that to ask. And now the table is in blue. So I press the blue second button and press table. And I see that not only do they happen to have the same solution, they're actually identical everywhere. So the original and choice 2 happen to be identical everywhere. Okay? How what happens if they're not identical everywhere? Well, like I said, they have to cross the x-axis at exactly the same place. So that's exactly what we would be looking for. Okay, I'm going to make it graph it again just by modifying the first one. I'm going to change this plus right back to a plus. If I look at the graph, this one happens to be color coded. So the first graph is in blue. And then I'm looking to see where the second one crosses the x-axis, but then I found out that the red one just completely overlaps the blue one. They definitely cross the same place because they're the same graph. So that's why choice 2 was the answer. So that's how I did this one. How would I have done this with process of elimination? Literally exactly what I just did. It just happened to be that the first one that I chose happened to be exactly correct. So let's just simulate. What if I didn't know to choose choice 2? Remember, I didn't know to choose choice 2. My random number generator says test choice 2 every single time. What if I decided to test choice 1? I subtract 24, and I would have gotten x plus 3 squared minus 24 equals 0. And so I would have graphed x plus 3 squared minus 24. Oops. And when I graph these, here's the first graph. I look at where these cross the x-axis right there. somewhere, right around 2 point something, and then the second one crosses the x-axis. Oh, slightly to the right, not exactly the same place, slightly to the right of a -8, and slightly almost looks like almost exactly at 2, not the same place as the blue one. So choice 1 is incorrect. So you see, by graphing, uh, by graphing, we were able to eliminate the answer. And in fact, by graphing, we would have eliminated choice 3 and choice 4 as well. Okay? So the answer is, in fact, choice 2. All right, I'm going to shrink this one in size. This is entirely too big. There we go. And now, numero nueve, number 9. The heights in inches of 8 football players are given below: 76, 70, 72, 70, 69, 71, 78, 74. Which box plot represents the data? Okay. Um, let's talk about what a box plot represents, how to get the box plot. Okay. I'm going to choose any of these because a box plot is what it is, independent of what the data that's in it. So the first number I could label as Q0, second number as Q1, the middle number as Q2, the third number is Q3, and the fourth number is Q4. What are these numbers? Q4, Q0 is equal to the min. Q1 is equal to the first quartile or the lower quartile. Just different names for the same number. Or Q2 is equal to the median. Okay. Q3 is equal to the third quartile or the upper quartile. And then Q4 is equal to the max. Okay. I like teaching it this way because this kind of clarifies, like if you ever do deciles, which I'm not going to teach, but deciles go from D0, D1, D2, all the way to D10. Split the data into 10 parts instead of 4. Okay. So the point then is, how do I determine what QZ, the min, the median, the max, and the first quartile and the third quartile are? So I first have to put the data in order. Okay. So put data in order. Okay. So if I put the data in order, I get 69 is the smallest number. Then I see two 70s. I'm going to put a dot on top, okay? I don't cross them out just because it hides the data a little bit too much. Then let's see, 71 is definitely going to be the next number. That's convenient because no other number can be next. Then I see a 76, 72, 78, 80. 72 is after 71. And then 74. And then 76. And then 78. Okay? And now that I have the numbers in order, put a dot there. Now that I have the numbers in order, well, the smallest number is the min. So that's easy. So that's at 69. So this equals 65, which doesn't equal 69. So that's not right. So this equals Q0 equals 65. Does not equal 69. So that one's not right. And now I have a passing problem. Passing problem, that's beautiful. Just from the min. And now I see that 69 is right here. 69 is right here. That's great. And now let's see the Q4. Sometimes that is enough to eliminate the answer too, but let's see. Q4 is the max, 78, but both of these have 78 as the max. So that doesn't eliminate any of the answers, okay? So what about the median? Let's talk about the median because these two have two different medians, okay? the median is the middle number. So if I look at the middle number, I'm going to put big dots here now. The middle number, I put one dot there at the ends, then another dot there and another dot there at the ends, then another dot there and another dot there at the end. Now I have two numbers in the middle. So which one of them is the median? It's actually the number in the middle of the two numbers. If there is just one number in the middle, right? If I put a dot and a dot, unfortunately, I don't have any numbers now in the middle. So what is the median? The median is the middle of those two numbers. If there's only one number left, that is the median. But there isn't any number left, so it's the middle of the two remaining numbers. So the median is the middle of 71 and 72 is 71.5. So the median is 71.5. That's Q2. But here, oh, 71.5. So they have, oops, no, wrong one. I already marked number 2 wrong. 71.5. And here, 72.5, Q2, 72.5 is not equal to 71.5. So that is incorrect. This one had the correct min, the correct max, but not the correct median. So choice 4 is incorrect. Okay? But because this has to be the GOAT of all review videos, I can't just stop at saying it's choice 3, because you have to know how to get the Q1 and Q3. So what's Q1, Q3, and the lower quartile? Now that we know how to get the median, that's the skill you need to get Q1 and Q3, the lower quartile and the other upper quartile. So really make sure that you know how to get the median. You go through all the points, and the middle number is the median. If there is no middle number, then it's the middle number of the two remaining middle numbers, okay? So in other words, the average of the two remaining middle numbers. So then what is Q1? Q1, the first quartile, is equal to the median of the left half of the data not including the median. So we start at the 71 and we get 69 to 71, and then 70 and 70, no numbers remaining. The middle number between 70 and 70 is just 70. So this is Q1. And so that's Q1. Remember, Q2 is 71.5. And then Q3, what is Q3? Q3 is the median of the right half of the data. Not including the median. So not including that 71.5 median, the 72 and 78 put a dot in there, and now there's two more numbers, 74 and 76, and now there's actually no more numbers there. So now I got to go between the 74 and the 76. The middle number is between 74 and 76 is 75. So Q3 is equal to 75. So again, remember, if there is a middle number, that middle number is the median. If there isn't a middle number, then the median is the middle of the two middle numbers. And there we go. That's how, and then how to construct a box and whisker plot. How to construct the box and whisker plot wherever your number line is. Okay. So I'm going to construct the box and whisker plot below this number line. Normally you construct it above the number line, but what you do is it's really this basic. You draw a vertical line at Q0, 69. You draw a vertical line at Q1, 70. You draw a vertical line at Q2, 71.5. You draw a vertical line at Q3, 75. You draw a vertical line at Q4, 78. Okay, so now you have, why did this turn into an arrow? Now you have 5 vertical lines. Okay, and now what do you do with these vertical lines? The two middle vertical, the 3 vertical lines in the middle, don't want that. I actually don't want a perfectly straight line here. The three middle vertical lines, you make a box. There's your box. And then out of the middle box, you draw lines, and those are your whiskers. There's your box and whisker plot. And if you notice, this box and whisker plot and this box and whisker plot are identical. And you might say, oh, but those whisker lines are not as tall. Sure. You want to make them smaller, make them smaller. You know? Boom. Tall, 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 short. Sure. Do it. Have your party. And now you know how to do a box and whisker plot so that if you get a part 2 problem like this, you can get all your points. And if you get a part 1 problem, you could definitely eliminate all the incorrect answers. Okay? Número 10, number 10. A bookstore owner recorded the number of books sold and the profit made selling books. And I do look at the table, but very cursorily because I come back to it. So that's my test taking strategy. Books sold 100, 250, 300, 350, and then profit 50, 275, 350, 425. So, for example, books sold 300, profit 350. Okay, great. Now I understand the table. Then I go on, and then I come back to the table after. I go on, what is the average rate of change in dollars per book between 100 and 350 books sold? The average rate of change. Is it 0.50 or 0.67 or 1.50 or 2.00? So these numbers are not completely egregious in terms of like 0.50 versus like 400 or something like that. So I do unfortunately need to know what average rate of change is, or it helps to know what average rate of change is. What average rate of change is how much money, in this case, how much money am I making for each book sold on average. Okay, but in this interval between 100 and 350, so I need to see between 100 and 350, I sold a bunch of books and I made, let me make this arrow a little bit clearer. I sold a bunch of books. In fact, from 100 to 350, I sold 250 books. And from $50, I ended up selling another 420, a total of 425. So I made another 375. Okay. So how do I get the average rate of change? How much money am I making for each book sold? Well, I see that I sold 250 more books and I made 375. So I definitely made more than $1 per book. So that crosses out choice 1 and choice 2, and now I have a passing problem. Passing problem, which is sweet. If every time I create a passing problem, I've created a problem in which I am not losing points relative to a passing grade. If I had a 1 in 4 chance of getting it right, let's actually do the what I would get if I don't do any of this process of elimination. If I have a 1 in 4 chance of getting it right out of 24 problems, then I get 6 right. Notice that the score, actually, let's talk about the score. 2 points per correct problem is 6 questions getting right times 2 points per problem is 12 points. If I just wild guess through the entire multiple choice. Okay, notice that means that if I wild guess through the entire multiple choice, it's not a 0. So you're actually starting with kind of 12 free points out of the 28 that you need to pass. But the problem is that for every question that I know how to do, it's not like I still have the 12 free points because now every question I know how to do subtracts from the questions I don't know how to do. And weirdly, that matters. So these strategies actually tend to matter a lot. So what if I eliminate one choice from every single multiple choice question? Well, 1/3 of the 24 questions times 2 points per question. That 1/3 of 24 is 8 times 2. just 16. That's actually a major number of points. That's 4 points just by eliminating one wrong answer, which we're doing with every single question. So we are guaranteed at least 16 points out of 28. But what if I eliminate what if I eliminate two choices out of every question? 1 and 2 out of 24 times the 2 points that each question is worth. That's 24. That's 12 times 2, which is 24, which is almost exactly a passing grade. Why I call these passing problems? Again, 24 and 28 are so close to each other. You get a couple of questions right, and you turn the rest into passing problems, you pass your test. Even without the part twos. But again, we still got to really talk about the part twos. And whether we should show work on the part ones. You notice that I'm showing work on the part ones. And of course, if you get every question right, 1 over 1 times 24 times 2, which is 24 times 2, which is 48 questions. Not only is this a passing grade, that's why we're putting so much focus on getting every question right. 48 points is actually a 74. That's before we even touched the multiple choice. So is it worth focusing a lot on the multiple choice? Yes. Now, should we show work on the multiple choices? Yes. And will I explain it on the next one? No, let me explain it now. Should you show work on the part ones? A lot of students say you're not required to show work on the part ones. And then you fight with your teacher from day one to the point where like May comes around and June comes around and your teacher is not super enforcing that because they have to pick and choose their battles. And you may go to a school where like every student refuses to show work and then your teacher doesn't make you show work, but you might be wondering why. You might be convinced at this point that it's not worth it. When really what's going on is that the teacher has to pick and choose their battles. This is a battle that unfortunately you should have let your teacher win from day one. So should you show work on the part ones? Yeah, you absolutely should. Let me see if I can highlight these. I can. Okay. It's not letting me highlight them. Okay. So should you show work on the part ones? Absolutely. And why? Well, the reason is that the part ones and the part twos are identical to each other. So if you don't show work on the part twos, you might be swearing that you're showing work on the part. If you don't know how to show work on the part ones, you might be swearing that you're showing work on the part twos, when really you're not. Because if you show work on the part twos to get maximal points, show that same work on the part ones, and that'll maximize your grade. So if you're showing work on the part twos in a proper way, you should be passing this test. Vice versa, if you're not showing work on the part ones, given that all the part one questions are part two questions, just with multiple choices, if you're not showing work on the part ones, you're really not doing what you need to do to get the question right. Because if you did show work, if you did know how to do the problem, you would be getting the points in the part twos, which means you wouldn't be getting a 65, you would be getting like a 90 or an 80. And in fact, this is an important fact. If you scroll down, look at this blank test. I've graded this test, I don't even know how many times, and this is what most tests look like. When in fact, most tests, you don't have to be able to see everything that I have here, but you do have to be able to see, so it's blurry, but that's okay. I just want you to see that all of these pages have an enormous amount of writing. And in fact, that's actually what your test should look like. Your test should look like the one I just showed you, all blurry, but with a ton of work on it, so that you can maximize your grade on the part ones. And then you do the same exact work on the part twos, threes, and fours, and you get an 80. And how can I prove that it's not just the tests that I'm looking at that have missing work on the part ones? The way I can prove it is that there should actually be a giant gap between like a 65, the number of students who get 65s, and the number of students who get an 80. And that gap should exist 65 and below for all the students who don't show work, and then 65 and then 80 and above for all the students who do show work. But the gap doesn't exist, which means that there's a ton of students who are getting lucky on certain problem sets and just getting points on the part twos, showing work on the part twos, but just refusing to show work on the part ones, which is why this entire gap between a 65 and an 80 is filled with a bunch of students who get those grades. If you are a student who's capable of getting a 65 and you show work your grade should actually immediately hop to about an 80. So show your work. And notice that you need a lot of points to get to an 80. From a 65, which is 28 raw score points, to an 80, which is a 61 raw score points, it's actually tougher to get an 80. But it's really easy to get to a point where you could guarantee a passing grade by showing work. Okay, that said, going to this problem, I have a 1 in 2 chance of getting it right. So now I could say to myself, well, selling 250 books, which answer do I think is right? Well, I think if I made $2 per book, I would have made an extra $500. So I think this answer is incorrect. So now this answer is looking very good. Fake student me has not just turned this problem into a passing problem, but has turned this into a problem where I'm almost guaranteed to get it right, because I've come up with a really good reason why I think choice 4 doesn't make sense. And in fact, if I trusted my math abilities, choice 4 just doesn't make sense. So now we have to define, because this has to be the GOAT of all tutoring videos. How do I do this problem? The average rate of change is equal to the change in the y, or change in x, or in this case, the change in profit divided by the change in number of books. And how do I calculate this? Well, that's equal to final profit minus initial profit divided by final number of books minus initial number of books. So that's equal to, now let's do the math, final profit 425 minus initial profit 50 at between 100 and 350. So they said this line and this line. That's why I'm doing those two lines. Divided by 350 minus 100, and that's equal to 375 over 250, and that's equal to 1.50 in my calculator. How do I get that answer? I just do the 425 minus 50. If I don't know how to do parentheses, which, by the way, you are required to put parentheses on the calculator, so I'll put them here. I'm trying to get into the habit of putting the parentheses in all horizontal fraction bars whenever I have to put it in the calculator, because, again, the diagonal fraction bar is not a grouping symbol, so you have to remember to put the parentheses when you're using the division in the calculator. Okay, so yeah, 375 over 250 is 150, and that is the correct answer. Our using correct math, we determined that 4 doesn't make sense, likely doesn't make sense. Fake student me said 4 likely doesn't make sense. Real tutor me says actually 375 over 250 is not 500 over 250. It's not 2. So real tutor me says 2 is definitely not the right answer. But fake student me might be lacking confidence, and so fake student me might have said 4 is likely not correct and 2 is likely correct, but still would have gotten it right. Numero 11, number 11. If f of x equals x squared, then which function represents a shift of the graph of f of x 4 units to the right and 3 units down? In this case, this is a great example of one that you could do on the calculator with 100% certainty. So I don't like clearing the calculator, so I'm not going to clear the calculator. I'm just going to clear the graph. I press enter on the equal sign, and that guarantees that it doesn't graph. Now I'm going to do x squared for y3. And now I'm going to do, I said that I would try choice 2. So I'm going to do parentheses x plus 4 squared minus 3. And now I remember 4 units to the right, it's to the right, and 3 units down, that's 3 units down. Okay, I'm looking for that. So the first graph is going to be my x squared. My second graph has to be the same graph, but 4 units to the right and 3 units down. So let's see what these graphs look like. I'm going to do zoom standard again. Here's my y equals x squared. And I could look for the vertex. Y equals x squared. 4 units to the right and 3 units down should be vertex around here. And look at the vertex in the wrong place. Choice 2 is eliminated. Many students think the answer is choice 2. This is the calculator. Many students think the answer is choice 2. They're like, well, let me add 4 to x and subtract 3 from y, and that's my answer. But they don't bother to check, even though they never actually knew how to do the problem. In other words, they say, I think this is how to do it. They select that answer and they move on. Bad strategy, isn't that? Saying, I think the answer is this and moving on. Now, I said for the purposes of the video, you could do that. But during the Regents, you absolutely shouldn't be doing that. You should be saying, I don't know how to do this problem. I think the answer is this. Let me just test this answer first. Or I don't know how to do this problem at all. Let me just start with choice 1. And you might be saying, is it really worth my time to do this problem the way I just did it? Well, I would argue using similar math to what we just did to find the value of a question, to find the value of a passing problem, for example, I would do similar math to determine the value of time used. I know students who would stare at this problem, not know how to do it, guess that the answer is choice 2, and move on. But if you do the value of 5 minutes divided by a quarter, 5 over a quarter is actually 20. But if you do a little bit of work to eliminate one choice, that let's say 6 minutes divided by a third is worth 18. That's a lower number than 20. This is weird math, but if it takes 7 minutes to plug in another problem and it happens to be incorrect, 7 divided by a half is 15, worth more. And then if it takes 8 minutes to check the final answer, 8 divided by 1 is 8. That's worth less. That's a smaller number. So doing the work is actually equivalent to using less time, even though you did use more time. That's if you trust the way I value my time. So if this isn't the answer, then what is the answer? So this is the thing that I want to be clear about, why testing answers is worth your time. Because if I wanted to test any other answer, I could just immediately go down and just modify this answer, like change this plus to a minus. And now I'm testing without plugging in. I just changed the plus to a minus, and now I'm testing choice 3. And now here's my original with a vertex at 0. Now I have to have a vertex 4 to the right and 3 down. Is this choice 3? Is this choice 3? Ooh, it looks like that's my answer. 4 to the right and 3 down. This looks very good. Now, I might not be guaranteed to be right, so I might test choice 1 and choice 4 to make sure that those answers maybe do or don't make sense, okay? But it does turn out that none of the answers are going to match. None of the answers are going to match this answer. Let me actually, something I forgot to do, to drag this over here so that I have that preserved, okay? So choice 3 is looking very, very good. And in fact, if you did the same thing with choice 4 and choice 1, it does turn out that choice 4 and choice 1 are incorrect. But how do I, again, do this problem? Okay, if I start with an f of x, any f of x, and I want to move it 4 units right, you would think that if like my first bit of intuition, if I had to move it 4 units right, I would guess that I have to add 4 to x, but it's actually the opposite. And I want you to remember this. In fact, every transformation that you do horizontally, you do whatever arithmetic is the opposite of when you would do the same transformation in the vertical direction. So in the vertical direction, if I want to move it 3 down, I'm going to subtract 3. If I want to move it 8 units up, 8 units up, I'm going to add 8. That means that if I'm going to do the same analogous thing or the analogous thing in the horizontal direction, I have to do the opposite. So now I'm just stating that as fact to give you a thing to remember. I'm not proving it, but it is true. So I'm going to subtract 4. If I move it in the positive direction horizontally, so if I move it in the positive direction horizontally, I'm going to subtract 4. Okay? So f of x minus 4. Okay? Now, this f of x minus 4, if I want to move it 3 units down, my intuition is that in the vertical direction, I'm going to subtract 3. And in the vertical direction, my intuition is correct. Subtract. So f of x minus 4, close parentheses, minus 3. And that's true for every f of x. It's not just polynomials. Literally every f of x, every function. So how do I remember it as a mnemonic? And how do I tutor it as a mnemonic? The thing is that every single student's intuition breaks in exactly the same way. The thing that they do vertically, the operation that they do vertically, has initially the expected outcome, and then the same operation done to x has the opposite outcome. And then the way I teach and tutor students to remember it is that that's true for every single function and every single operation. If you remember that, to do the opposite operation as you would do vertically, the opposite operation to x as you would do vertically to f of x, then you get the question right every time. Stretch it vertically, multiply by 2. Stretch it horizontally, divide x by 2, for example. 2 steps done vertically, do those 2 steps algebraically in that order. 2 steps horizontally, 2 transformations done horizontally, do those 2 transformations using the inverse operation that you would normally use vertically, and do them in the opposite order. Works every time, okay? But at this point, we've confirmed that the answer is choice 3, because we've subtracted 4 from x to move it to the right 4 units, and we've subtracted 3 from everything from f of x to move it 3 units down. Okay, numero 12, number 12. The amount of money a plumber charges is represented by the function P of h equals 45 plus 90h. The best interpretation of the y-intercept of this function is that the plumber charges $45 to come to the house, or $45 per hour that he works, or $90 to come to the house, or $90 per hour that he works. Now, I see, and I agree, that there's no guarantee in real life that these variables represent anything really specific, but that's actually the reason why they asked about the y-intercept. However, there is a certain amount of reasonableness about the function's look. And I noticed that P of 0 is equal to a charge for 0 hours. And that's equal to 45. And that's the y-intercept. So this one is looking, the $45 to come to the house is looking very good. Now, real tutor me knows already that choice 1 is the answer, but fake student me is liking that answer, so I put a checkbox next to it. Now, I told you that what I would do if I know the answer is incorrect. I put an X on the number, and if I think the answer is incorrect, I put an X next to the number, next to the answer on the right. If I think the answer is correct, I put a checkbox next to it, and if I know the answer is correct, I just circle it, like you always do. Now, how about choice 2, $45 per hour? What does the y-intercept represent? $45 per hour that he works. Well, the y-intercept is unchanging. And that's equal to the constant coefficient, okay? So it's not multiplied. by the variable. So that one is incorrect. Okay. Now, what does the y-intercept? This one actually makes sense. $90 to come to the house. To come to the house. Again, this is the 0, but it's just 0 hours. So come to the house makes sense. Come to the house makes sense, but it's the $90 is not the amount that he charges at time 0. P of 0 does not equal to 90. And that's why choice 3 is incorrect. The $90 per hour that he works, this is true, but not the y-intercept. In other words, he does charge $90 per hour, but it's not the y-intercept. Okay, that's why that's not the right answer. Okay, now this is the first 2x2 problem that I didn't get to explain what a 2x2 problem is. But for this one, number 13, I get to explain what a 2x2 problem is. So that is nice and convenient. So we'll talk about what a 2x2 problem is. So number 13, numero 13, what is the solution to the inequality 2m minus 4 less than or equal to 3 parentheses 2m plus 4? Okay, is it m less than or equal to negative 2, or m greater than or equal to negative 2, or m less than or equal to negative 4, or m greater than or equal to negative 4? Now, problem 12 was what I call a 2x2 question. Okay, I'm just going to take a really quick look to see. Problem 8 was also a 2x2 question, and problem 5 was a 2x2 question, and I think that's it. But you don't know what a 2x2 question is yet. So let's actually talk about what a 2x2 question is. Do you have to draw this box when you're doing a 2x2 question? No, but I'm going to draw a box. Okay, so this is a 2. This is a really phenomenal test-taking strategy. 2 by 2 question. In fact, I usually write 2 by 2, meaning that they're not asking the answer choices. If you notice, they're not just 4 unique choices, totally different looking. There's two pairs of choices that look similar. So I'm going to draw a box. Okay, 2 of the choices. Okay, let's draw this box. 2 of the choices have a less than or equal to, and 2 of the choices have a greater than or equal to, and 2 of the choices have a negative 2 on the right side, and 2 of the choices have a negative 4 on the right side. So now, what am I saying about this 2x2 question? Why is this a 2x2 question? Suppose I'm a very struggling student, and I am not 100% sure how to do this question. I may look at the fact that they're asking 2 different questions in this question. Is it less than or equal to or greater than or equal to? And then also, is it a negative 2 on the right or a negative 4 on the right? And then get overwhelmed by the fact that I have to answer 2 questions simultaneously when I'm just wrong about answering 2 questions simultaneously. I'm actually being able to answer 2 questions separately. And that's not overwhelming. So I may not be able to solve the inequality at all. Suppose I'm that kind of student who doesn't know how to solve the inequality at all. But I am able to recognize, since both of these answers have a negative number on the right side, I might be able to answer the less than or equal to versus the greater than or equal to by plugging in, let's say, m equals 0. So if I get 2 times 0 minus 4 less than or equal to, now this is a question mark because I don't know, I'm testing. Less than or equal to question mark, 3 times parentheses 2 times 0 plus 4. So I got 0 minus 4 less than or equal to 3 times 0 plus 4. I got negative 4 less than or equal to 3 times 4. Now, by the way, if you didn't know 0 minus 4 is negative 4, again, predict but verify. I think it's negative 4. Go to my calculator. This is not an arithmetic test. This is an algebra text. Do the arithmetic on the calculator. Negative 4. 3 times 4 is 12. 12. And is negative 4 less than or equal to 12? This is true. Okay? Therefore, 0 is in the solution set. Okay? So which ones have 0 in the solution set? Less than or equal to 0, less than or equal to -2. So hold on. First off, I gotta say this. M less than or equal to -2 is choice 1. M less than or equal to -2 is 2. M less than or equal to -4 is choice 3. And M less than or equal to -4 is choice 4. Now, which ones have 0 in the solution set? 0 is not less than or equal to -2 or -4. So this actually crosses out choice 1 and choice 3 are crossed out. And so choice 1 and choice 3 are crossed out. Notice that I've eliminated 2 choices without necessarily knowing how to do the problem, just by eliminating the less than or equal to in this case. Because 0 is less than or equal to -2 is false. And 0 less than or equal to -4 is false. But here, 0 greater than or equal to -2 is true. So now this has a checkbox. And 0 greater than or equal to -4 is true. So this has a checkbox too. So 2 and 4 both have a checkbox. 1 and 3 both have an X. Now I have a passing problem. And a subscribe button. A subscribe button on the right. Well, actually, when the video is vertical, I don't even know where the subscribe button is, but I think it's on the right. Well, how do I get the answer? Supposing I don't know how to do the question. Well, actually, now I have a strategy that works, that I know works. Plug in a second value. How about plugging in? I have to plug in something that differentiates between choice 2 and choice 4. So something that is in one of the solution sets, but not in the other. Now, this one is from -2 and above. Okay. And this one is from -4 and above. I got 0 and I got -4 here. So I got to get something that is in one of them, but not the others. Everything to the right of -2 is in both solution sets. So I got to maybe like a -3 is not in this solution set, but it is in this solution set. So I could plug in like -3. And that will, with a 100% certainty, give me the answer. So I want to tell you that even if you don't know how to do this question, you now have the ability to get the answer. I will also say this. When students work with negative numbers and they're struggling students, which means that if you don't know how to do this inequality, chances are maybe you struggle a little bit. Students who struggle also struggle with negative numbers. Let your calculator do the negative numbers for you. Don't make up, I think the answer is this. Let your calculator do the arithmetic for you. You are taking an algebra test, not an arithmetic test. Your calculator could do the arithmetic for you. Let it always do the arithmetic if you struggle with arithmetic. Just be humble. Best advice that I could give you. Honestly, if you just struggle with arithmetic, just letting the calculator do the arithmetic for you is 10 free points on the test. That might be the difference between passing and failing already. Just that. Just that. So but at this point, I'm not going to simulate plugging in because you literally plug in the same way I plugged in that. But let's actually do the problem. Let's actually do the problem. So I got 2m minus 4 less than or equal to 3 parentheses 2m plus 4. I can't cancel anything out because everything on the right side is stuck inside this multiplication. So I'm going to do the distributive property to get rid of those parentheses. I got 2m minus 4 is less than or equal to 3. Nope, 3 times 2m. 3 times 2 is 6, so 3 times 2m is 6m, plus 3 times 4 is 12. Again, I got a calculator installed in my brain, but if you don't, use your calculator. You got a calculator installed in your hand or on the desk. Now, I'm going to get the m on the right because a lot of students like it that way, but that's going to force me to review something in our algebra, which is really helpful. Minus 6m, minus 6m, And again, do the arithmetic on your calculator. 2 minus 6 is negative 4. So negative 4m minus 4 is less than or equal to 12. Okay. And then, let's see, I'm going to add 4. Add 4. And I got negative 4m is less than or equal to 16. And now I'm going to divide by negative 4. I'm going to divide by negative 4. And this is where students struggle on part ones and part twos. In fact, you'll notice that this confirms that the ones with twos can't be correct. So that already, even if I struggle with arithmetic, this confirms that the m greater than or equal to negative 2 is not correct, because I'm going to end up with a negative 4 on the right side. And now that, even if I don't know how to work with inequalities with arithmetic, I can get the answer as choice 4. Isn't that great? So multiple ways of getting the answers. I often tell students there's up to 10 to 20, maybe even 50 ways of doing the problem correctly doing algebra, but there's up to thousands and literal thousands of ways of eliminating all the incorrect answers. And that's not facetious. That's totally true. The reason is that the moment you're trying to eliminate incorrect answers, you are much more free to use an enormous number of methods that don't necessarily apply to the correct answer. So that said, when I multiply or divide both sides of an inequality, by a negative number, the inequality is reversed. Okay? So I actually, when I tutor, I train my students the moment I'm going to simulate this for my students. The moment they divide by a negative number, I simulate them. The first thing that they write is actually the reversed inequality before they write the rest of the arithmetic, so they don't forget to reverse the inequality. And then I got m is greater than or equal to 16 divided by negative 4 is negative 4. Okay? And so m is greater than or equal to negative 4, confirming that choice 4 is, in fact, the correct answer in now the third way. Okay? Número 14, number 14. A survey of students at West High School was taken to determine a theme for the prom. The results of the survey are summarized in the table below. And I do read the table cursorily before moving on. I see Beach Party, Hollywood, Broadway. I see Girls and Boys, and I see a bunch of numbers: 86, 112, 68, 123, 77, 79. So they're distributed in interesting ways. Approximately what percentage of the students who chose the Broadway theme were girls? 26%, 27%, 46%, or 68%. Okay? So this is a great problem to think about on your own before you see how I do the problem. So this one says, though, what percentage of the students who chose the Broadway theme were girls. Let me choose a non-black color for now so that you could see it over the black lines. Were girls. So we want to know what percent are girls. Of the only the students who chose the Broadway theme. So only the students who chose the Broadway theme. Now I notice that there's fewer girls than boys in this category. Which means the answer is less than 50%, which eliminates with 100% certainty choice 4. This is an example of a problem where I'm not going to eliminate every single incorrect answer. But I notice here, choice 4 is eliminated. But in fact, 68 is quite a bit, so it's not like super duper close to 79. But if I notice these answers, 26% and 27%, this is approximately 25%. Or 1/4. These two answers, the number of girls would be tiny, around 3 times less than the number of boys. Or equivalently, the number of boys is 3 times more than the number of girls. In other words, if there were 20 girls, there would be approximately 60 boys. If there's 68 girls, 3 times that is like almost 200 and almost 210 boys. There's only 79 boys. These are way too small. Way too small. And we've actually confirmed that choice 1, 2, and 4 don't make sense. We confirmed choice 4 doesn't make sense because it's greater than 50%. And for a different reason, we've confirmed that 26% and 27% don't make sense. So notice that test taking strategies can give us the correct answer, 46%. So now that we know the answer, might as well do the problem so that we can confirm that the answer is right. Now, notice that I confirmed that choice 1, 2, and 4 are incorrect. I crossed out 1 at number 1. That's fake student me crossed out number 1, number 2, and number 4 with 100% certainty. Does that mean that I should do the problem if I know it's incorrect? If I know it's correct? Well, if you're the kind of student who is so good at math that you're near 100%, your goal is to get 100 on this Regents, you should you should go after you're done with the test and redo the problem after you're done with the test. If you struggle and you're barely doing it in time, you just confirmed, if you're a fake student me, you just confirmed that choice 1, 2, and 4 are 100% incorrect and choice 3 is the only answer that could be correct. You should circle 3 and move on. Okay? But because this problem could be a part 2 question. This is definitely a part 2. I've seen this problem basically with different numbers on part 2s. I've seen this problem on part 3s and on part 4s, in fact. But if you go to number 40, if you go to the numbers, the percent for girls is equal to the number of girls in, let's say, in the Broadway group, divided by the number of students in the Broadway group. And so that's equal to, well, it's 68 over 68 plus 79. And this is now a situation where I need to put parentheses if I'm going to put this in the calculator. Let's move this up here. On 68 divided by parentheses, 68 plus 79, close parentheses, and I get. Now this is a test taking strategy that I'm going to teach you right now. What I do when I train students, obviously you can't take a screenshot and put it onto your test, so that doesn't work. What I actually train my students to do is, this is a muscle memory fixer, is to put the entire number, 0.462585,034, which is approximately 46.2585,034%. Okay, why do I do that? And then look for how they want you to round it, and then round it, 46%. Why do I teach students to do it that way? So step 1, write the whole number, entire number. 2, round how they want. Oh, okay. Round how they want. The reason I actually recommend it is because as a tutor, as a teacher, I could work with you for many days on things that are the correct way and teach you the correct way, but over time. But because this is a video, And when I tutor, I don't have the luxury of working with you for multiple times. So I have to come up with strategies that fix incorrectness that don't compete with the muscle memory that you already have. And I found that teaching it this way fixes muscle memory for any student who does it wrong when rounding incorrectly. So if you always just write the entire number and then round to how they want, it it dodges any muscle memory that makes you round to the wrong thing. So we rounded to 46%, the whole percent, and we confirmed that the answer is choice three. And you'll see me do that on choice on the part twos, threes, and fours a lot. Now, um, about the subscribing, uh, uh, if you don't want to hear me talk about subscribing, go ahead and skip. But until I get to number 15, number 15. But about the subscribing, the reason I do ask for the subscribe, and you'll see that I finally got to 1,000 subscribers. My last video, which was only recorded, uh, um, maybe like 3 weeks ago, I literally had uh like 800 and something subscribers, 860-ish subscribers, and my goal has been to get to 1,000 subscribers. The reason is that I want to get so if you're watching this video, chances are you've already gotten a couple of interruptions with ads. Maybe you've gotten lucky and you haven't gotten any ads yet. But the thing is that I need one, I need 1,000 subscribers, and two, I need a certain number of watch hours to be able to put ads on the video. So right now, all the ads that get put on this video, before the video, after the video, and unfortunately sometimes in between the video, all of that money goes to YouTube. When I get my 1,000 subscribers, which I now have, and when I get to 4,000 view hours, uh, then and notice I have 149,000 and 420 views, but most of those are on shorts, but not on long form videos. When I get to the 4,000 views, and it has to be within a 365-day period, then I uh, I get to keep the ad revenue instead of YouTube, or I get to keep a lot of the ad revenue instead of YouTube. And honestly, the reason I do these videos, well, is because over time I've I started tutoring at a very low price, and then I started I started working with very discerning clients as I found out that actually not only was I good at tutoring, but I was phenomenal at tutoring. And I get that's a brag, but of course, when you're working in a business, you kind of have to occasionally brag, and that's just unfortunate. So I really do a phenomenal job with my tutoring clients, and they progress tremendously. I have turned students with a 60 into students with a 98 in like 3 sessions. I've taken students who have like a 450 on the SAT, the math portion of the SAT, and they just want to get a 500 so they can get into this one college, and then they get a 670. I've gotten students who get a 550 and they just want to get to a 600 or a 650 and got them to 780. I've gotten students, and this is extremely common, especially on the ACT, which is the test that I recommend over the SAT. Uh, on the ACT, I've had students take the test and get a 22, and then work with me for like 3 sessions and get a 33. And for nationally, the average increase after tutoring is only 4%. So we're talking about a 22 increasing to like a 23 after tutoring for many, many, many hours. Me, I tutor 3 times, and my students usually go from like 22 to like 33. So, but I, because of that, my clients tend to be very discerning, and they I charge accordingly. And I've always wanted to have a free arm of my tutoring business. This is the free arm of my tutoring business, but the way I fund this or will fund this is through ad revenue. So if you feel that up to this point I've been helpful, please do click the subscribe button. I really do appreciate it. I do also ask any questions in the chat because again, this is the free arm of my business. I do answer questions that are in the chat. Okay. All right. On that point, numero 15, number 15, the sum of 2 radical 54 and 2 radical 6 is 4 radical 60, 8 radical 15, or 7 radical 6, or 8 radical 6. And a fun fact, again, a lot of, if they use different words on this question, you might actually struggle with how to do this question. But most students, more than 90%, actually more than 95% of students know that sum means addition. So if you add these numbers, you get the sum. So even if you don't know how to do the question, you can plug those numbers in, okay, to the calculator. The sum, so I do 2, radical is above the x squared buttons in blue, so I press the blue second button. I press the, oops, not right the button, okay, press the blue 2, press the blue second button in radical, 54. Then the sum, so plus 2 radical 6, and I get a decimal. And it's unfortunate that I get a decimal, and it is irrational, so it's going to stay a decimal. But one of these answers is going to equal that. So I promised you that I would check number 2. I'm going to do 8 radical 15. If this is the same decimal, it's got to be the answer, and it's not. It's around 30. So the sum is around 19. This is around 30. So this is not correct. And it turns out that if you actually are eagle-eyed, you notice that choice 1 and choice 2 are the same number. And since there can't be 2 answers that are correct, they both have to be incorrect. So then the answer is actually either 7 radical 6 or 8 radical 6. And check out what fake student me says. Check this out. This is a strategy that used to work when I was a kid so strongly, and now barely works, but occasionally we get lucky. I noticed that coefficient of the radical is even, too, and I noticed this coefficient of the radical is even. So after simplifying the radical, I'm still going to have an even coefficient, and when I add them, I'm still going to have an even coefficient. This one has an even coefficient of a radical. This one has an add coefficient of a radical. So fake student me suspects that choice 3 is incorrect, but real tutor me knows that everything I just said is 100% correct, and therefore 3 is actually incorrect. But the point is that I could do this problem by plugging in if I still didn't know how to do it, I could plug in choice 3 or choice 4. 7 radical 6. I got to get 19 change. I don't. And then I do 8 radical 6. And I get 19 and change, which is the answer. Okay. But how do I do this question? So I've confirmed that this answer is incorrect and that this answer is incorrect. But how do I get this answer using using arithmetic? What if they asked us to simplify the radical completely, especially if this is algebra 2 or something like that? Well, I know 2 radical 54 plus 2 radical 6. I can't add these because these have 2 different radicals. But if I simplify radical 54 as 2 radical, I got to factor out a perfect square radical, radical 9 times radical 6, plus 2 radical 6. Now, what this does for me is that radical 9 is equal to 3. 2 times 3 radical 6 plus 2 radical 6. And now I can multiply the 2 times 3 by the associative property. I get 6 radical 6 plus 2 radical 6. And just like 6x plus 2x is 8x, 6 radical 6 plus 2 radical 6 is 6 plus 2 radical 6, also known as 8 radical 6. 6, which is choice 4. Okay? And the calculator told us that if I didn't know how to do it. So I really didn't have to know how to do it. I could use my calculator to get it. Número 16, number 16, the functions f of x equals x squared minus 5x minus 14 and g of x equals x plus 2 are graphed on the same set of axes. What are the solutions to the equation f of x equals g of x? The calculator can do it for me, but I might as well plug in 0 and check, because 0 is one of the choices, or choice 1 and choice 2, and that'll eliminate 2 answers quickly. Remember, plugging in the easy choice is a great way to eliminate answers. F of 0 is equal to negative 14, or I could just say, remember, okay, so 0 squared minus 5 times 0 minus 14. So 0, 0 minus 14 minus 14, and then g of 0 is equal to 0 plus 2, which is equal to 2, not equal to negative 14. So that eliminates choice 1 and choice 2. And I have a passing problem. Passing problem. Just by plugging in x equals 0, plugging in the easy number. So how can I get between choice 3 and choice 4? I could plug in. Negative 2 is part of both choice 3 and choice 4, so plugging in negative 2 doesn't make sense, although it could help to check my answer. But plugging in 7 and or 8 will 100% confirm what the answer is. So plug in 8. And again, I'm not going to simulate plugging in every number because that's a waste of your time. But plugging in negative 8, you could plug in negative 8 or negative 7 by saying y equals okay. So let's see, x squared minus 5x minus 14, and g of x is x plus 2. But I promised I was not going to simulate plugging in negative 8. So, or 8 and 7. So let me scroll away so you can't see it. And then I plug in negative 2, and they are equal at negative 2. But of course, that didn't tell me anything. That at least confirms that I did it right. And I'm going to scroll away from 7 and 8 again so you can't see it because I'm going to let you do it yourself. Although, of course, you could just rewind and see what that was, right? But that said, I'm going to show you how I would, well, that's how I would do it by plugging in. So I guess I really do need to do that. But it looks like the answer is 8. But the other way that I would do it, besides going to the table, is graphing it. Okay. So zoom standard. Okay. So they're equal at negative 2, and then they're equal somewhere here, but I can't tell where they're equal. So how do I get that answer? I go, you see above trace is the calc in blue, so I press the blue second button in calc. And I'm going to calculate the intersect of two functions. The first function, enter. Second curve, enter. Now I have to guess. I do have to guess. I have to get somewhat close, and it does help to get really close. Okay. Enter. And I got x equals 8. And that x equals negative 2. Luckily, I don't have to verify that one because it's actually just right on the graph. It's right there. Okay. So that is the answer. So either the table or the graph. So it's funny because I was saying I wasn't going to simulate it, but the truth is that the problem had to be done that way. The problem had to be done. The problem could be done that way. I guess I circled number 3, but I try to not circle the answer because if students don't watch me do it algebraically, but this can be done algebraically, and this is a part 2 algebraically. How do I find when they're equal to each other? I set them actually algebraically equal to each other. X squared minus 5x minus 14 is equal to x plus 2. Now, would I normally do this problem algebraically? I actually wouldn't do this problem algebraically normally. I would actually just let the calculator do this one for me. But again, part 2 could be algebraically find the solutions to this equation. So now I have that. In that case, in a part 2, I would have to do it algebraically. So minus x minus 2 minus 2, and I get x squared minus 6x minus 16 equals 0. And luckily, a is equal to 1, b equals negative 6, and c equals negative 16. Luckily, a is equal to 1, and this factors with integers. If this didn't factor with integers, I would have to start using the quadratic formula. So blank plus blank equals b, which is equal to negative 6. And then blank times blank equals negative 16, which is equal to c. Notice I have to check that a equals 1 first. If a is not equal to 1, this is 1. Okay. So numbers that add up to negative 6 and multiply to negative 16, I do the factor rainbow with 16, 2, 8, and 3 does not satisfy the conditions. 4 does. 4 times 4 is 16. And now I've gotten to the biggest number on my list, 4. Or rather, I should say my numbers on bottom grew, my numbers on top shrank, and they met at 4. So I could stop. This is the full factor pair list. Which factor pairs, which when I put a negative on one or both of them, give me -6 as a sum and -16 as a product. So if I do 2 as one of the numbers and -8 as the other number, 2 plus -8 is -6, and 2 times -8 is -16. And since a is equal to 1, I could immediately factor x plus 2, x minus 8 equals 16. Equals 0. The zero product property allows me to say since the product equals 0, one of the factors is equal to 0. So x plus 2 equals 0, or x minus 8 equals 0. And I solve each of these equations separately, -2 minus 2. I get that x is equal to -2, and plus 8, and I get that x is equal to 8. And nothing is making me reject any of the answers. There's no physical constraints that make me reject any of the answers. So those are my two answers, confirming algebraically in a way that you would do a part 2 that choice 3 is the answer. Número 17, number 17. If x equals 4a squared minus a plus 3 and y equals a minus 5, then which polynomial is equal to the product of x and y? Is it -17a squared minus 2a minus 15? Or -17a squared plus 8a minus 15? Or 4a cubed minus 21a squared minus 2a minus 15? Or 4a cubed minus 21a squared plus 8a minus 15. Okay. If you happen to know that some key words here, you could actually do a lot with this problem. First off, you do need to know this key word in math. Product means multiplication. Okay. Now, what are some strategies for process of elimination? If I multiply these, 4a squared minus a plus 3 times a minus 5. If I recall that a minus 5 is the same thing as a to the, let me get the blue, a to the first minus 5, then when I multiply the 4a squared into the a to the first, I'm going to get a 4a cubed. So I get a 4a cubed, I get a 4a cubed. This does not have a 4a cubed. So choice 1 and choice 2 are incorrect. Now I have a passing problem. Great. Now, even if I didn't know how to do this problem, I have a 50-50 chance of getting it right, even if I wild guessed. Okay. Now, unfortunately, plugging in, as I told you, plugging in like a equals 0 is a great number to plug in to confirm whether the answer is correct. But in this case, you're just going to get 3 times -5 is -15, which both choice 3 and choice 4 have that value. But if you plug in almost any other number, you're going to find that the answer is likely confirmed. I gave you the hint that easy numbers to plug in are 0, 1, roots, and other special numbers. In this case, if you plug in x equals 5 or a equals 5, plug in a equals 5, this product just immediately equals 0. Saves you a ton of time. So you might say it's not worth plugging in 5 into this. But sure it is. It's going to get you 2 points on the test, as opposed to wild guessing right now, which gets you 1 point on the test. And if we're playing a game of numbers to try to get a passing grade, why sacrifice a point? You're literally that close to passing. Why sacrifice a point? Literally, the way that the statistics work is that if you, on average, are averaging around a 65, then on like a randomly chosen Regents, you might get anywhere between a 60 and a 70. And if you look on the grading sheet, between a 60 and a 70, so in other words, between a 28, you might get +2, plus 4 points or -4 points. You're going to get between a 32 and a 24. So you are not playing a game of 0 to 82 if you're just barely trying to pass. By the way, you shouldn't be just barely trying to pass. You should be trying to get as many points as humanly possible. Because on a transcript, a 67 looks better than a 65, a 70 looks better than a 67, a 75 looks better than a 65, an 80 looks way better than a 65. Look at that, an 80 looks way, way, way better than a 65. But you're not playing a game of 0 to 82, so with huge numbers. You're playing a game of like 4 points. 4 points above or 4 points below. So is your 1 point worth it? Your 1 point on this question is literally increasing your chance of passing by 25%. If you're just trying to get an 80, probably also increases your chances of getting an 80 by 25%. If you're trying to get a 90, probably also increases your chance of getting a 90 by 25%. And if you're trying to get 100, then you just have no choice because you got to get every point. So if you plug in A equals 5, it will confirm the correct answer. Okay? And that's not always true, but in this case, it is. Okay? And if it's not true, it's just that in general, it's an easy number to plug in, right? The easy numbers to plug in can be quick confirmations. But again, I have to do this problem in a way that could be done on a part 2. Okay? So this is called the each with each method or the box method. They're both equivalent, and they're better than like FOIL. Each with each and FOIL look exactly the same on a multiplication of two binomials, but then FOIL fails horribly when you're working with a trinomial. So you really do need to do like each with each or box method. So I'm gonna multiply these out. 4a squared times a is 4a cubed. And a times minus a is minus a squared. And then 3 times a is plus 3a. And then minus 5 times 4a squared is minus 20a squared. And minus 5 times minus a, you need to know that negative times a negative is a positive. So plus 5a. And if you don't believe it, try negative 5 times negative 1 on your calculator. Negative 5 times negative 1 is 5. So negative 5 times negative 1a is plus 5a. And negative 5 times 3 is minus 15. And now I can combine like terms. Actually, I can combine like terms in this case diagonally. I get 4a cubed. These two. Minus a squared minus 20a squared is minus 21a squared. That confirms that. And then plus 5a plus 3a is plus 8a. That confirms that and makes that look very bad. And then minus 15. Confirming that choice 4 is the correct answer. Now I give you a way to get the answer even if you didn't know how to do it by plugging in numbers. In fact, I told you how to get the answer by plugging in easy numbers. 0, unfortunately, didn't eliminate answers. 1 would be an easy number to plug in, but 5 is a nice easy number to plug in because it just gives you 0 immediately, so you know you got to get 0. But you don't have to plug in nice numbers. Plug in 9. Plug in 11. Plug in, if you want to get really, really crazy, you could like plug in pi. But you could plug in 1.1. 1.1 is sufficiently crazy for 99.9% of problems. And I'm not exaggerating with the 99.9%. Literally, 1 in 1,000 problems, 1.1 is not going to do it for you. Or less. So like in the 100,000 problems that I've seen on the Regents, might be that big. Talking about 100 where 1.1 doesn't work, it's even less than that. It's way less than that. 1.1 may actually work as a number to plug in for every single problem that I've ever seen. I could easily construct a problem where it doesn't work. It's just, I'm saying though, they haven't. I don't think. I'm not going to remember if of the 100,000 Regents problems that I've seen, if one of them had 1.1 as a solution. So, but 1.1 is a great number to plug in. 11 is a great number to plug in. If you want to get really, really, really crazy, pi is a phenomenal number to plug in. Although pi stops being a great number to plug in Algebra 2, so. And definitely not in calculus. 18. Número 18, number 18. What is an equation of the line that passes through 3, 7 and has a slope of 2? Y minus 7 equals 2 parentheses x minus 3. Y minus 3 equals 2 parentheses x minus 7. Y plus 7 equals 2 parentheses x plus 3. Or y plus 3 equals 2 parentheses x plus 7. All of these have a slope of 2. So that's a limit. That doesn't help. So done. Okay? That doesn't eliminate any answers, any of the answers. So now you might be wondering, what is going on here with these numbers. So this is actually a 2 by 2 question. It's not necessarily obviously a 2 by 2 question. But I want to show you that it is a 2 by 2 question. Okay. Where is the 2 by 2? The questions are choice 1 and choice 2 have a minus and a minus as the operations. And choice 3 and choice 4 have a plus and a plus as the operations. And then choice 1 and 3 have the numbers 7 first and then a 3 in that order. And then choice 2 and 4 have a 3 first and then a 7 in that order. Okay? In that order. And now, let's see. So the ones that have minuses with a 7 and a 3, that's choice 1. Minuses with a 3 and then a 7, that's choice 2. Pluses with a 7 and then a 3, that's choice 3. And then pluses with a 3 and then a 7, that's choice 4. Now, you don't have to draw this box. It helps, though, to recognize it as a 2 by 2 question because it could feel overwhelming if you try to answer both of the questions. Is it minus minus or plus and plus? And simultaneously, is it 7 and then 3 or 3 and then 7? But if you separate the questions, which you just totally can, it actually makes it easier. And in fact, I see that this is the x coordinate and this is the y coordinate of a point. Therefore, the operation has to be done to x and with a 3. And the operation done with an x has to be a 3, and the operation done with a y has to be a 7. So this one, choice 2, has it in the wrong order, and choice 4 has the wrong number next to the y and the wrong number next to the x, and choice 4 also has the wrong number next to the y and the wrong number next to the x. So 3 and then 7 are incorrect. Choice 2 and choice 4 are incorrect. This is a passing problem by recognizing it as a 2 by 2 question. Now the question is, do I subtract the 3 from x and subtract the 3 from y? I'm sorry, do I subtract the 3 from x and the 7 from y, or do I add the 3 to x and add the 3 to y? Well, then I remember that I actually have to subtract from the thing that I told you earlier. Okay? I have to subtract the 3 from x. So this is looking great. And this is looking bad. And then you might say, wait, but I'm subtracting the 7 from y. But the other one you said, I would add the number to the f of x. Both of those things are correct. Because the other ones, you're doing an operation on f of x and then calling that y. This one, you're doing the operation on the variable letter y itself. Okay, so how do I actually do this one if this was a part 2 question? The point slope form of a line through the point, parentheses x1, y1, with slope m is y minus y1 is equal to the slope m, parentheses x minus x1. So in this case, this is x1, this is y1, and this is your m. Okay, so y minus y1 is 7. Okay, is equal to m2, parentheses x minus x1 is 3. Leaving this one as the correct answer. If you feel that was helpful, again, it does help me to click the subscribe button, but only if you feel I deserve it. Número 19, number 19. A geometric sequence with a common ratio of -3 is -10, -7, -4, -1, dot, 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 or 14, 11, 8, 5, dot, 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 or -2, -6, -18, -54, dot, 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 or 4, -12, 36, -108, dot, dot, dot. Okay, So I'm not going to draw the 2 by 2, but this is actually technically a 2 by 2 question. This is the question, though the reason this could be interpreted as a 2 by 2 question is, are you doing an operation with a plus 3 or a negative 3? And are you adding or multiplying? That's literally a 2 by 2 question. There's actually other ways to interpret this as a 2 by 2 question, which means that this question invites a lot of ways of using process of elimination to eliminate some answers. Now, this one, I noticed that if I just add 3, I get the next term. This one, if I subtract 3, I get the next term. Now, this one, I might wonder what I need to do to get the next term. I'm actually multiplying by 3. Negative 2 times positive 3 is negative 6. This one, multiply by another 3, and multiply by another 3. And this one, if I multiply by negative 3, I get to the next term. Okay? So now, just this might be enough to get you the answer, especially if you remember that a geometric sequence, I'm multiplying by the common ratio. So I'm multiplying the current term by the common ratio to get the next term. Okay, so now the thing is that which one am I multiplying? I'm multiplying in choice 3 and choice 4, but in choice 4, I'm multiplying by negative 3. In choice 3, I'm multiplying by positive 3. So, and this one has a negative 3, but it's not a multiplication. And this one has a plus 3, and it's not a multiplication. So the only one that has 2 checkboxes is choice 4. Well, how do I do this problem, though? Before I circle choice 4, because that's it. So the common ratio, that's equal to it's equal to A2 divided by A1, but it's also equal to A3 over A2, okay? But it's also equal to A4 over A3. In general, it's equal to AN plus 1, the next term, divided by the current term. Okay? So I can actually calculate the common ratio. They told me that the common ratio is negative 3. So I could just test choice 2. Test choice 2. Is this equal to A2 over A1, 11 over 14? I mean, not even negative 3, not even close. So choice 2 is incorrect. I also confirmed already, I confirmed that it was incorrect because I was subtracting 3 instead of multiplying by any number at all. But choice 2 is incorrect. But literally, the way to do this problem is get the common ratio of each one. So you test choice 1, negative 7 over negative 10 is also not negative 3. Choice 3, if you do negative 3, is this equal to negative 6 over negative 2? Or is this equal to negative 18 over negative 6? Or equal to the next one? Okay, so in fact, negative 6 over negative 2, so many students get this question wrong by just assuming the ratio. That is a very common but incorrect strategy, incorrect cognitive dissonance. Cognitive dissonance, the reason it's cognitive dissonance is because you may know that you struggle with negative numbers, but you still don't bother plugging it into the calculator. That's not laziness. I don't call that laziness. I call it cognitive dissonance because it's something that you don't know how to do, but you accept as true anyway. Cognitive dissonance is the belief of two contradictory things. Humans need a capacity for cognitive dissonance in order to make sense of the world. There's too many complexities of all the things that we're doing, so we have to start making assumptions about how the world works. So But the problem is when we start using that in math, where there is a right and a wrong answer, we then apply what we think is true without verifying it, or we have two contradictory beliefs, and we have to choose one, and we sometimes choose the wrong one. So, for example, -6/-2, a lot of students don't know that -6/-2 is +3, +3. Whereas, so this is 3. Whereas 4, choice 4 is -3 equal to, on choice 4, -12/4, and is it equal to 36/12, and is it equal to -108/36? And in fact, we go to the calculator again, and in fact, -12/4 is -3. 36 over -12 is 3. -108/36 is -3. So these are all the ratios are -3. So there's a common ratio, and that common ratio is -3. Okay. Number 20. When the equation 6 minus ax equals ax plus 2, minus 2 rather. Sorry, let me read that again. When the equation 6 minus ax equals ax minus 2 is solved for x in terms of a, and a is not equal to 0, the result is 4a, 4 over a, 2a, or 2 over a. Now, as a student, you may struggle to do some process of elimination for this one. And many students struggle with process of elimination with this one. And check out this strategy for process of elimination. So I'm solving for x, right? Solving for x. Now x is being multiplied by something involving a. Therefore, I have to divide by something involving a. Okay? And then there's nothing cancels the a in the denominator. Therefore, the answer has a in denominator. Now, this is just in general, somewhere in the denominator. So choice 1 is not the answer. Choice 3 is not the answer. That is a nice little strategy that helps me simplify the problem a little bit. I have a passing problem. I might struggle so much with algebra that I have no clue how to do this, other than the fact that I'm going to divide by the coefficient of x because I got to solve for x. And there's an a in the coefficient of x involved. There's no a's in the terms that don't have an x. So nothing is going to cancel the a in the denominator. So the answer is going to have an a in the denominator. Choice 2 and choice 4 are the only ones that have a in the denominator. Number 1 and 3 are incorrect. Okay. By the way, this is actually technically a 2x2 problem. You might not see it that way, but the question is it a 4 or a 2? And is it times a or divide by a? So that's one way to interpret it as a 2x2 question. So 2x2 is, interpreting it as a 2x2 is a really useful way of doing the problem. So how do I do the problem algebraically? 6 minus ax equals ax minus 2. Now, I might struggle with this question, but suppose I struggle with this question because I don't know how to finish it, but I do know that if I add 2, I get that 8 minus ax equals ax. And I say to myself, if I divide 8 by a number, if I divide 8 by 2, I get 4. If I divide 8 by 4, I get 2. So then I could ask the question, am I going to divide by 4 or by 2 at some point to get a 4 or a 2 or a 4, I might realize I'm not dividing by 4 to get a 2. So I have to have a 4 in the answer and not a 2 in the answer. And even if I don't know how to do the question, that interesting fact allows me to cancel um, choice 4. Or a fake student me might not be 100% confident with canceling choice 4, so I put an X next to choice 4 and a checkbox next to choice 2. And if I really am stuck and I have nothing else to do, I now have an answer choice. But if I have something I can do, here's the thing, and here's another piece of advice. A lot of students stop at this point because they're convinced they don't know what to do, when in fact they might not know how to finish. If I'm solving for X, I gotta get X on one side. So one thing I can do is add AX to both sides. Okay? I might not know how to combine this, but that piece I might actually know I have to do. Another thing is, what if I didn't know to add AX? What if I wanted X on the left side? Then I have to subtract AX from both sides. Either one of those choices would have led me to a correct answer. So what's my point? My point is, don't say, I don't know how to finish it. Ask yourself, do I know how to take any step next? And if you do, if you know how to start the step because you might find that you know how to finish the step. I added AX and I get that 8 rather. Okay. 8 is equal to, now AX plus AX is 2 of those AXs, so 2AX. Now I have to solve for X. I might not be comfortable dividing by A, but let me divide by 2 right now. And suppose that fake student me didn't realize that I had to have a 4 in the answer, but I divided by 2. Now fake student me now is sure that the answer is going to have a 4. Now that does confirm that choice 4 and choice 3 are both incorrect. Now fake student me has eliminated 3 choices despite convincing myself that I don't know how to do the question. I got the answer right, choice 2. But let me finish it. Divide by A. X is being multiplied by A, so I do the inverse operation with the same number. The inverse of multiplication is division with the same number A. And I get that X is equal to 4 over A, exactly choice 2. We are 20 problems through towards a perfect grade on this test. I'm really excited. I'm really stoked. I hope you guys are too. If you are stoked and excited about possibly getting a perfect grade on this test, please do click that like button. Again, subscribing does help me a lot. This number 1,000, by the way, subscribers, it might go up or down in the middle of this video because this is live. Now, your subscribe isn't going to show up right now because this video was recorded in the past, but your subscribe will be one of the many numbers that show up in my next video. So I do appreciate it if you do click that subscribe button. It does help me tremendously. I only post right now at least Regents videos. I'm trying to think of what other kinds of videos I could post, but we'll see. Número 21, number 21. Which function has the zeros -1, 3, and -4? F of x equals x plus 1, x minus 3, x minus 4, or g of x equals x minus 1, x plus 3, x minus 4, or h of x equals x plus 1, x minus 3, x plus 4, or k of x equals x minus 1, x plus 3, x plus 4. I thought that they could have made this problem a little bit tougher, but they didn't. What is it that makes this problem a little bit easier? I noticed that the -1 and the -4 have the same sign, so whatever operation is done, the same operation has to be done with the -1 and the -4. So there either has to be a +1 and +4 or a -1 and a -4. It can't be like +1 -4, like this one, +1 -4. They don't match. So that one's incorrect. And it can't be a minus and a plus. These don't match. And that one's incorrect. Choice 2 and choice 3, -1, x minus 1, x minus 4, and choice 3, x plus 1, x plus 4, those match. And in fact, the other one, the other argument I could make is that the operation with the 3 has to be the opposite of the operation with the -1 and the -4. But unfortunately, choice 2 and choice 3 match that as well. Now, which one is it? +1 or +1 and +4 and -3? Or is it -1, -4, and +3? For the same reason that a transformation done in the horizontal direction has the has I'm sorry, an operation done to x has a transformation done in the opposite direction of the operation. The root, when in factored form, has to be subtracted from x. Okay? So, by the way, I should say before I do this, there is a strategy that will eliminate choice 2 or choice 3. Plugging in a root. You know that -1, 3, and -4 are roots. Plug in x equals 3 and see which one gives you 0. Only choice 3 is going to give you 0. Choice 2 is going to give you, plug in x equals 3. We get 3 minus 1, 3 plus 3, 3 minus 4, which is equal to 2, 6, and -1, which is equal to -12, doesn't equal 0. And this one gives you a 0. But the root is subtracted from x. Let's do it the proper way. We got x minus parentheses -1, close parentheses, x minus just a plain old 3, and then x minus parentheses -4. X minus -1, you do need to know that minus and negative is the same thing as plus. So x plus 1, there's no avoiding that. X plus 1, x minus 3, x minus -4 is the same thing as x plus 4. And that does match choice 3. The reason there's no avoiding knowing that is that part 2 questions exist, and 3 and 4. So you do need to know it for part 2s, 3s, and 4s. Número 22. The expression 5 to the power of a plus 2b is equivalent to 5 to the a times 5 to the 2 times 5 to the b, or 5 to the a times 25 to the b, or 25 to the 2ab, or 25 to the a plus 2b. Okay, this one actually, we could do a lot with process of elimination here, believe it or not, to eliminate some choices. One is, notice that this is the only difference in writing with 5 to the a plus 2b is the base. So these can't be equivalent. Because 5 does not equal 25. Okay? So that's not the answer. So now we have a 1 in 3 chance of getting it right. Now you might say, that's not worth my time to eliminate one choice, but notice 1/4 of 2 points is equal to 0.5 points, but 1/3 of 2 points is equal to 0.66 repeating points. When you might say, wait, 0.66 repeating points, what's that worth? That's only a few decimals statistically more. But again, you're playing a game of numbers. And so if you do that with 3 questions on let's say 12 on 12 questions, because now that's a multiple of no, let's do 3 questions. On 3 questions, that's 2/3 of a point times 3 is 2 points. But 1/2 of a point times 3 is only 1.5 points. 6 questions, that would be equal to 2/3 times 6 is 4 points. But a half times 6 is 3 points. 4 points versus 3 points. That's a gain of a full point. And remember, you are not playing a game of 0 to 85. You are playing a game of +4 and -4. So plus a point is a significant amount. In fact, statistically speaking, plus 1/6 of a point is a significant amount if you're only playing a +4 -4 game, not a +0 to 85. All right, so is there anything else that we could do to eliminate some choices? If A equals B equals 0, I got 5 to the 0 is equal to 1. And this is equal to choice 1 would be equal to 1 times 25 times 1 is equal to 25, which is incorrect. So choice 1 is eliminated. Okay. Now, unfortunately, choice 2 and choice 3 would both be equal to 1, so it doesn't eliminate a choice, but we got a passing problem. We eliminated choice 1 for a really phenomenal reason, and we eliminated choice 2 by taking a test point. Can this problem be done by taking test points? Yeah, actually. Take a different test point. Let A equal 0 and B equal 1. In fact, I think that will eliminate choice 3. And now you got the answer without knowing how to do the problem. Okay? So you can do this one with process of elimination. Now, how do we do this problem algebraically? Because, of course, this could be a part 2 problem. There's rules. There's exponent rules that you've been taught since like 5th grade. I know it's hard to remember all these rules, but b to the power of, let's call it m plus n. So if you're adding exponents, that's equivalent to multiplying at the base level. And if you're multiplying exponents, that's equivalent to taking the base to one of the powers and then exponentiating again with the other power. Notice that what this seems to imply is that when you bring the operation from the exponent down to the base, it kind of increases the level of the operation. And what do I mean by increasing the level? You have addition and subtraction in PEMDAS below multiplication and division, and that's below exponents. And then, of course, that's below parentheses. And parentheses, of course, really means grouping symbols. So what I'm saying is that a multiplication in the base is equivalent to an exponent at the, and multiplying at the base is equivalent to adding at the exponents, and exponentiating at the base is equivalent to multiplying at the exponent, and vice versa. Adding in the exponent is equivalent to multiplying at the base, and multiplying at the exponent is equivalent to exponentiating at the base. So it does really kind of bring it down a level. And there is something called above exponentiation, which we never learn in Algebra 1 or even Geometry or Algebra 2 usually, called tetration, which is an operation above exponentiation. It's a derived operation. It's a repeated exponentiation. And it behaves that same way. Anyway, so what this implies, 5 to the power of, so I'm going to call this rule 1, rule 2. 5 to the power of a plus 2b is equal to, according to rule 1, 5 to the a times 5 to the 2b. And that seems to contradict choice 3. But maybe you're not confident with that yet. But according to rule 2, 5 to the 2b could be split up a little bit. So 5 to the a stays the same, and 5 to the 2b could be split as 5 to the 2, that to the b power, and 5 to the 2 is 25, and this is equal to 5 to the a times 25 to the b, which is identically choice 2. On that note, número 23, number 23, we are 2 questions away from being done with a perfect multiple choice section. In an arithmetic sequence, the first term is 4 and the third term is -2. What is the common difference? Now I do need to know the common difference is the number that I am adding to get the next term, to generate. So I'm adding, let's say I'm adding to the current term to generate the next term. Now, why is it called the common difference if I'm adding it? But notice that the common difference, which by the way, we normally use the letter D, and it's equal to, well, that's the second term minus the first term, but it's also equal to the third term minus the second term, or whatever the next term is minus the current term. Or, I mean, it goes to A20 minus A19, or in general, AN plus 1 minus AN. It's called the common difference because all of these differences are in common. Okay? So notice that A1 plus D is A2, A2 plus D is A3, A3 plus D is A4. So we are adding D to get the next term, but the reason it's called the common difference is that you're literally taking the difference of successive terms, and it's always the same number, D. Okay, so what if I didn't know that, but I wanted to do some process of elimination? Well, the first term is 4, the second term is missing, the third term is -2. How do I get to -2 using a -1 or using a -2? Plus blank and plus blank. That doesn't allow me to do it. Okay, but what about the -3 and the -6? Do I add -3 or do I add -6? Some students notice that 4 plus -2 is -6, but they're not successive terms. I'm sorry, -2 minus 4 is -6, but they're not successive terms. So that's why some students get this answer, but it's actually incorrect. And I suspect it's incorrect. Fake student me is suspecting that this one's incorrect because -2 minus 4 is -6. But I learned from JuanTutors.com that the common difference is not the third term minus the first term, it's the second term minus the first term, or the third term minus the second term. So if I do the third term minus the first term and I get -6, chances are the common difference is something else. So, and in fact it is, if I add -3, and I add -3, I get to the correct answer. But what I could do is I could just try some numbers and see if I get to -2. If I try like -3, or if I try 4 down to 3, doesn't get me to -2. If I try 4 down to 2, then I get to 0, right? If I try 4 to 1, 4 plus 3 is -1. 4 plus -3 is -1, and then 1 plus -3 is -2. So this is correct. And if I add -3 to both 4 and to -1, I get the correct answers. Okay. But yes, let's leave it there. Número 24, last question before we could say we got a perfect grade on the multiple choice section. Número 24, number 24, Joe is ordering water for this swimming pool. He determines the volume of his pool to be about 3,240 cubic feet. There are approximately 7.5 gallons of water in 1 cubic foot. A truck load holds 6,000 gallons of water. Which expression would allow Joe to correctly calculate the number of truckloads of water he needs to fill his pool? So the answer has to be number of truckloads divided by a number of pools. Okay? Why am I saying that? I like every time I explain this question, I try to explain it in a different way because the truth is that the way to explain it, it is a good skill to have. So I am going to show how to do it using the skill. But at the same time, if you don't know the skill, you might be stuck with not knowing how to do this question. So how to eliminate answers? Cancel. So find the units by canceling units in the numerator with units in the denominator. And if I do that, I notice that the choice 1 has in the denominator gallons and the numerator gallons, so those cancel. So the final, and that's the only thing that appears in the numerator and denominator. So the final units is some number of foot cubed times foot cubed divided by pool times truck load. The units on this one, nothing cancels because all the units are in the same place. All the common units are in the same place. The final units is some number of foot cubed times truckload divided by a number of pools times gallon, or gallon squared. Foot 6 times truckload over pool times gallon squared. Is that how you tell me how many truckloads you need? I've never heard that, right? This one, I see foot cubed and foot cubed cancel. And this one, and that's the only things that cancel. And so this is equal to some number of gallon squared over pool times truckload. Whereas this one, if I cancel the units that are in the numerator and denominator, feet cubed and feet cubed cancel. And actually also gallon and gallon cancel. And this one has some number of truckloads divided by pool, which has the correct units. It's the only one that has the correct units. So you can do this one just by canceling units to make sure the units make sense. How do I do this problem, though, if it were a part 4 question? Because this is a really common part 4 question. So we want to know how to do it to get at least our partial credit. Well, we start with the thing that needs to be converted. Start with the numbers to be converted. And then 2 multiply by ratios that ratios that are equal to 1 and cancel undesired units in the numerator and denominator. So that's how we do this problem. So Joe is ordering water for a swimming pool. He determines that the volume of his pool is 3,240 cubic feet. So we need to convert that to truckloads to fill his pool. Okay? So how do we do that? The number of cubic feet is 3,240 cubic feet per one pool. Now we want to convert to truckloads per pool. So the thing that we need to eliminate, we already have pool in the unit, but we have to eliminate the cubic feet. So there are approximately 7.5 gallons per cubic foot. This allows me to convert the cubic foot per gallon. So do I put notice that a ratio, 7.5 gallons over 1 cubic foot is equal to 1, because 7.5 gallons is equal to 1 cubic foot. They told us that, okay? But that means that 7.5 gallons over 1 cubic foot is equal to 1, but also 1 cubic foot over 7.5 gallons is equal to 1. How do I know where to put what number where? Well, I need to cancel cubic feet. So I need to put cubic feet in the denominator, and I need to put gallons in the numerator. So notice it wasn't the gallons that told me where to put the numerator. It was the cubic feet that told me where to put the denominator. This one cancels that. And now I still don't have truckloads, so I need to cancel out gallons. But this tells me 1 truckload. Wow. Equals 6,000 gallons. Which means the ratio of these two numbers is equal to 1. But I need to know where to put the denominator. Again, and the numerator, that I need to cancel gallons. So gallons goes in the denominator, and truckloads goes in the numerator. 1 truckload is equal to 6,000 gallons, and that cancels that. And I could actually stop at that point because they're not asking me to continue with that. This exactly matches choice 4, which we had already confirmed by eliminating units in the numerator with units in the denominator. Okay? And now we have a perfect multiple choice section. And how many points did we get so far? 48 points. 24 times 2 is 48. So we have a 74 guaranteed, and that's before we go to part 2. So now I want to point out the very first question is to graph a quadratic and then to state the minimum. In a part 1, they could literally graph it for us and then ask us the minimum. They could give us the minimum and ask which graph matches that. So these questions really do match part 1 questions. So how do I graph this to get full credit? This is where I want to say neatness counts. Okay? What do I mean by neatness counts? Well, the reason neatness counts is that if your graph does not look sufficiently accurate, you lose points. If you write a word, and you notice my handwriting, and I do mean it, that I'm doing my best that to write as neatly as possible. I have a random stray mark here. I've never been diagnosed with a specific reading writing disability, but it's there. So my handwriting's sloppy, but what's my point? Even though my handwriting's sloppy, I have a random stray mark here, but a reader would be able to tell that that's just a stray mark. My O, this one closes. My U might look like a V. My A doesn't close. It could be a C or a W. But when you put all the letters together, you could read my handwriting. A graph, though, the exact location of things has the meaning. So if you just decide you're just going to be sloppy about where you put things, that's not worth anything, because it's the location that matters. If you decide you're going to move a point over because you want it to be more visible, it's wrong, because the location is the thing that matters. If you're supposed to graph a perfectly straight line and you don't use a straight edge, it's wrong, because a straight line is perfectly straight. If you decide to draw a parabola, which is not perfectly straight, it's curvy, but you decide to use a straight edge, it's wrong, because a parabola is not perfectly straight. So you just have to graph it fairly accurately. You can construct a table of values manually, X, Y, and do, for example, 0 and 1, 1 plus 4 plus 1 equals 6, 2, You get 4 plus 4 plus, no, 4 plus 8. Oops. Four plus 8 plus 1 equals 13. And etc. You could do it manually, or you could do this with the calculator. So I want to show you that you can do this with the calculator, and it is extremely, extremely useful. Turn this on. I'm going to make this a little, it's just going to let me make it a little bit smaller. Okay. I'm going to say y equals, scroll down. I use all these, so I'm going to undo the graph. I keep them so I could check my answer later more efficiently. But I do, if I use more than 10 functions, which I think this is what this has. If I use more than 11, yeah, more than 10 functions, then I have to delete some. But let's see, I do x squared plus 4x plus 1. And I could graph this to see what this looks like on a standard graph. Zoom standard. It's a nice parabola. It doesn't have integer roots, so I can't force it to have integer roots. It's a nice parabola. Doesn't dip too low. But I could actually use my table to get the table of values. And I want to have, so I noticed that this graph goes up to about 10. So I want to have up to about 10. So there's my table. Make this a little bit smaller so that I can make this a little bit bigger. And now in your case, you would have your calculator in your hand. And you can transfer this table of values if you want. -3, no, -1, you could do it in any order, -1, -2, -2, -3, -3, -2, -4, 1, -5, 6, -6, 13. You could transfer it onto your paper. It's actually not required. I heard one teacher say it is required, but I've graded this Regents 1,000 times. It's not required. So I plot the points. Now notice, this is one of the points 0, 1 that a lot of students just move because they want it to be more visible. But the moment you move it to the left or to the right or up or down, it's just wrong. You don't want it to be more visible by moving it to the wrong place. You want it to be more visible by making it darker. Okay, so 0, 1. Actually, I'm going to go to the -5. -5, 6. And you can mark these. So -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. Let me put this 5 on the other side to help me see things better. Okay, so 5, -5, 6. -5, 6. -4, 1. -3, -2. -2, -3. -1, -2. 0, 1. 1, 6. And 2, 13. Okay, so those points are graphed perfectly. Okay? So now how do I connect these? If I decide that I'm going to connect this with a straight edge, it's incorrect. So if I graph this, I notice, which I already did, I noticed that the graph is nice and smooth. I can't draw perfectly smooth on paper. So what's the deal? If I draw a straight line, I have to use a straight edge. I could draw that perfectly straight because I have a straight line. So if I have to draw a curvy line, I can't use a straight edge, but I have to draw it perfectly curvy. That's the point where we know you're working with a pen and your hand. So how accurate does your graph have to be? I know the graph is going to blow up over here, but notice there's a little bit of jiggliness. That was not supposed to turn straight. Come on, there we go. It takes so long to fix itself. Okay. So you're not expected to be able to draw it perfectly straight or perfectly curvy, but it goes through the point. It keeps to between the x equals -5 and x equals -4. Okay. And goes through that next point. Let me try that again. Why does I let go of the pen. It shouldn't have straightened that. And goes through that point, and goes through that point, and goes through that point, and goes through that point. I'm gonna pick up my pen for a little while. Goes through that point, goes through that point, goes through that point, and then blows up, but doesn't pass 2. And then I draw arrows at the end. Why do I draw arrows at the end? Because this function does continue that way. This is a full credit question, a full credit graph. Now, could I real tutor me had made a better graph? Yes, but I needed to simulate myself as a student so you could see that the graph doesn't have to be perfectly neat, but the minimum meanings have to be there. The arrow that this does continue forever in this direction, this arrow that it does continue forever in that direction, and it crosses all of these points, that has to be there. And then generally the direction of the curve. But like a little jiggliness, you're not expected to have a perfectly mechanical computerized hand. So this is a perfectly acceptable and full credit graph. Now the next one, state the coordinates of the minimum. The minimum, you could write them right here. That's at -2. And down here is -3. So parentheses, -2, comma, -3. That is the minimum. Yes, I do need the parentheses. I have seen students not use the parentheses and lose points. Okay, full credit. Número 26, number 26. If f of x equals 30x squared plus over x plus 2, determine the value of f of 1/2. Lots of ways of doing this question on the calculator. I highly recommend actually employing the calculator to do this question. Notice that there's addition in the denominator. I need parentheses. I could just plug in 30 for the numerator. Now the 1/2 has a fraction, so I have to use parentheses. 1 divided by 2 squared, close parentheses, divided by, open parentheses, 1 divided by 2. You can put the 1/2 in parentheses again, 1 divided by 2, and I'm gonna because parentheses 1 divided by 2, close parentheses, plus 2, close the full parentheses for the denominator. Yes, enter. 3. But I can't just write 3 and get full credit. If I just write 3, I get 1 credit, by the way. If you just write 3, you get 1 credit, so that's good. But can I do this neater? This is when I'm going to show you how to write the fraction as a fraction. So parentheses 30 times parentheses. Now look at this. If I press the math button, I go to number, and the very last option, n over d, it allows me to write a neat fraction, 1 over 2. Close parentheses, squared. Close parentheses, divided by, open parentheses. Another neat fraction 1/2. 1 over 2. That plus 2. I didn't need the parentheses for the 1/2 because the 1/2 is now in a horizontal fraction bar. But enter, I still get 3. And in fact, wait, this is a fraction nested inside another fraction. So f of 1/2, to show full credit, I actually have to write this. 30 parentheses 1/2 squared over 1/2 plus 2. I did that with horizontal fraction bar. Can I write that in the calculator? Yes, I can. You can have nested fractions. Whoa, hey. That's cool. I could do math, fraction. I'm going to do the fraction, 30, parentheses, another fraction, 1 over 2, close parentheses, squared. That divided by a fraction, 1/2. 1 divided by 2. That fraction plus 2. Do I still get 3? Yes, I do. Okay, so let's put that in there. Okay, so how do I get full? Oh, it just did some funny things. Let's fix that. That's one of the problems with dragging that image in. Uh, how do I get full credit? I write 30 parentheses a half squared over 1/2 plus 2, and then I could write 3. Why can I just write 3 after I plugged it in? One, you have to plug it in and show that you plugged it in. But two, you could just give the answer at that point because this is not an arithmetic class. This is an algebra class. You are not required to know how to do the arithmetic. You are required to know how to do the algebra. So if you did 30 times 1/2 squared equals 30 times 1/4 divided by 1/2 plus 4 over 2 equals 30 over 4 divided by 1 over 2 plus 4 over 2 is 5 over 2. Is that equal? And that's equal to 30 over 4 times, flip the second and multiply 2 over 5. And then cancel the 5 with the 5 here and you get 6. Cancel the 2 with a 2 and you get 2 here and you get 6 over 2 equals 3. If you did all that, you get full credit? Sure. But if you did this, do you get full credit? Also yes. Which is why I recommend letting the calculator handle your arithmetic for you. You don't have to do the arithmetic on paper at all. Okay. Número 27, number 27. I explain why the relation shown in the table below is a function. So this one actually is just directly, and then the second part, complete the table below with the values of both x and y, so then the relation is not a function. This was literally directly asking you, do you know what a function is? Do you know what a function is? Well, that's a good question. Do you know what a function is? Ask yourself if you know what a function is. I remember from high school and middle school, my teacher said that a function passes the vertical line test. In other words, there is no vertical line that passes through the graph twice. Or in other words, x coordinates can't repeat. This in this relation, the only x values are at -1, 0, 1, and 2, and they do not repeat. So they're asking explain why the relation shown in the table below is a function. I could say that each x coordinate maps to only one y coordinate. Done. That's actually what makes a function a function. That's the only condition that a function requires. If a relation maps each x coordinate to at most one y coordinate, then the relation is a function. If the relation fails that, so some x coordinate literally anywhere maps to more than one y coordinate, then the relation is no longer a function. That's what a function is. A function maps x coordinates to at most one y coordinate. So the second part, and that's a point for 27. Second part, complete the table below with the values for both x and y so that this new relation is not a function. Now I have to have an x coordinate. I need not a function. I need an x coordinate to map to more than one y coordinate. So I pick any of these x coordinates, -1, 0, 1, or 2. I'm going to pick, what did I choose in my paper? I chose the number 2. And I map it to anything except 5. I chose 4. Now, I noticed that 2 maps to 5, but 2 also maps to 4. So y is not a function. Now, you might say, wait, but it's a table, so isn't it a function? No, if it's in a table, it's a relation. The condition that a function has to satisfy is that each x coordinate maps to at most one y coordinate. At most one. At most one. And this 2 maps to 2 different y coordinates. That's not at most one. That's more than one. Número 28, number 28. We are approaching a perfect grade. That is phenomenal. And I want to point out, if you noticed in the explanations, which I know we didn't talk about because in this case, there's not much to say here, uh, but it is worth talking about. Each correct question in a part two receives 2 points, 2 credits. Okay. Here it also says that you have to indicate the necessary steps. This is why if you can't get the credit for part two because you don't know how to do it, you literally really don't know how to do the part one, which means you do have to show work on the part ones. So if you do know how to do the part twos, if you do know how to do the part ones and you're not lying to yourself, then you know how to do the part twos. Vice versa, if you don't know how to do the part twos, you don't know how to do the part ones. And the big thing is to show work. Okay. Formula substitution diagram, graph charts. Okay. Use the information, and I want to put the word all here. And remember what I said. Cross out the words not necessarily drawn to scale and put almost definitely. Okay. And it does say that a correct answer with no work does receive a credit. So if you just give the number, like here, the minimum -2, -3, you get a point. Here, you just put 3, you get a point. Here, you put 2, -4, you get a point. Or 2, 4, or 2 and anything except 5, you get a point. Or 1 and anything except a 4, you get a point. Or -1 and anything except a 2, you get a point. Okay. Number 28, number 28. Solve algebraically for x. 0.05 parentheses x minus 3 equals 0.35 x minus 7.5. Do you remember in the previous section, part 1, with the multiple choices, I said that this could easily be a part 2 question? And here it is, literally a part 2 question. A part 1 question and a part 2 question that match exactly. Big difference is that this one has decimals and the other one didn't. But as we learned, the test does not want you to know how to do arithmetic. The test wants you to know how to do algebra. Let the calculator do the arithmetic for you. So I had to do the distributive property, get rid of these parentheses so I could play with everything else. 0.05 times x is 0.05 x minus, and you might not know, this is me just really quickly simulating big student me. You might not know what 0.05 times -3 is. So 0.05 times -3, and I get -0.15 minus 0.15 equals 0.35x, 0.35x minus 7.5. And this is where it's important. Again, you want to know how to do the algebra. We don't care that you do or don't know the arithmetic. Well, I missed the x here. So that's a common error, by the way. I missed the x here. That would definitely cause huge errors. So what's my point? I might not know how to combine like terms, but I do know normally if this was like a 3x or a 7x or a 2x, I would subtract the 3x or the 7x or the 2x. So just it's 0.35x, so I have to subtract the 0.35x. And I could say to myself, I don't know how to do 0.05 minus 0.35, and this is where I pull out my calculator because I do know what 0.05 minus 0.35 is, but big student me doesn't. But big student me also knows that they don't care about me doing the arithmetic on paper. I just need to know the number, -0.3. So -0.3x minus 0.15 equals -7.5. And then I have to add 0.15, add 0.15. And I do, again, I don't know how to add. Fake student me maybe doesn't know how to add negative and positive numbers, which is, again, it's disappointing, but it's okay because the test is not testing you on your arithmetic skills. -7.5 plus 0.15 is -7.35. So -0.3x equals -7.35. And now I have to divide by -0.3. Divide by -0.3. Again, why do I divide by -0.3? If that was a -3, I would divide by -3. If that was a -4, I would divide by -4. If that was a -7, I would divide by -7. So the fact that it's a decimal that I'm not comfortable with doesn't change the fact that the operation is multiplication. It's the operation that tells me what to do. I do the inverse operation with the same number. Inverse of multiplication is division. So to eliminate the multiplication by -3, I divide by -3. I'm sorry, instead of to eliminate the multiplication by -0.3, I divide by -0.3. I get that x is equal to and I don't know how to divide. In this case, I don't immediately know the answer of negative 7.35 divided by negative 0.3. Okay, yes, I do. But I do it on the calculator. Negative 7.35 divided by negative 0.3. And if you're wondering how I did it in my head so quickly, even though I didn't say the answer is 24.5, the way I did it in my head so quickly is that I multiplied the numerator and denominator by 10, and I changed it to negative 73.5 divided by negative 3, canceled out the two negative signs, 73.5 divided by 3, 72 divided by 5 is 24, 1.5 divided by 3 is 0.5. And so I get 24.5. But you don't need to know how to do that on paper, in your head. You just use your calculator. And look, full credit. Full credit. Full credit. Let's try circling that again. Okay. We are cruising towards a perfect grade on this Regents, and I'm loving it. I'm loving every single second of it. Number 29, numero 29, use the quadratic formula to determine the exact roots of the equation x squared plus 3x minus 6 equals 0. They said to use the quadratic formula. In this case, this is the first time I look at the formula sheet, but the formula sheet is available to you. And a lot of the formulas are formulas that you'll need in higher level classes. But a lot of the stuff that we did is on this formula sheet. Geometric sequences is there, although we did it without using that formula. Arithmetic sequences is there and often is necessary, but we did it without that. Compound interest, we haven't used it yet, and we may not. Exponential equation. Here is the quadratic formula. The quadratic formula counts on having written the equation in standard form. So I'm not gonna just screenshot the quadratic formula. I'm screenshotting the standard form also. Okay. And for the quadratic formula, you have to have equals 0. So a equals the number in front of x squared, which is equal to 1. So this is an ax squared plus bx plus c equals 0 form. B equals 3. And c equals negative 6. And then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I plug into this, x equals negative 3 plus or minus the square root of b3 squared minus 4 times a is 1 times c is negative 6 all over 2 times 1. Now, when I teach this, I want my students to know how to do the arithmetic. But again, this is not an arithmetic test. So I have to simplify the radical. This is not going to simplify into rational numbers, unfortunately. So I have to simplify the radical. Let the calculator handle it. 3 squared minus 4 times 1 times negative 6. Oops, negative 6. 33. So I got equals negative 3 plus or minus radical 33 over 2. 2 times 1 is 2. And the problem's done. Lots of students get points off by doing the arithmetic in their head. I recommend not. I recommend not doing that. Numero 30, number 30. Factor 5x cubed minus 80x completely. I would highly suggest trying this problem on your own because you might find that you convince yourself that you don't know how to do this problem. You know what happens with a lot of cases? A lot of students get to a point where they convince themselves they don't know how to do the problem and then start making up crazy rules. And sometimes you just have to do that to get something done. But what if you didn't make up crazy rules? What if you started with the statement for yourself? I'm not going to start with crazy rules. I'm going to start with things I know are true. And then if I get to a point where I don't know how to do something, then I could start inventing. I noticed that 5x cubed minus 80x has a common factor of 5. I could factor out of 5, parentheses, x cubed minus 80 minus 80 divided by 5. This is where I simulate my non-arithmetic skills. 80 divided by 5 is 16, but suppose I didn't know that. 16x. And then I realized, oh, the x cubed and the x have a common factor of x. So I can factor out an x out, and I get x squared minus 16. And this is already worth a point. Now, this x squared minus 16 is a difference of two squares or a difference of perfect squares. And so what is the difference of perfect squares? If you have p squared minus q squared, that's actually equal to p plus q, p minus q. And why is it a difference of perfect squares? Because p squared is a perfect square and q squared is a perfect square. So either way, if you call it dots or dops in your school, or never heard of these terms, p squared minus q squared is equal to p plus q times p minus q. Where p is x and q is 4. Why is q 4? Because 4 squared is equal to 16. Okay? So, let's see. So I got 5x, parentheses, x squared minus 4 squared. Which is equal to 5x, according to the dots or dops, x plus 4, x minus 4. And that is a full credit factorization. Let me try circling that again. Full credit factorization. All right. So what about, part 3. Part 3 is different from part 2. How is part 3 different from part 2? Part 3 is worth 4 questions. Now, what's the difference between part 3 and part 2 in reality? Well, now they get to ask the similar questions or questions having to do with the same concept and split it up into multiple parts or ask more complex questions in general. So the good part, you might, and I know a lot of students who say, I'm going to skip the part 3s and part 4s and focus on the part 2s because part 3s and part 4s are just way too hard. I don't know how to get any of the 4 points. That's probably a lie. If a problem is split into 4 points, that means that it actually allows for just a tremendous, tremendous amount of partial credit. A tremendous amount of partial credit. So if you don't know how to do the first part and you just make up an equation and you make up a random correlation coefficient, but you state what that random correlation coefficient means, you get a point for the second part. For the third part, rather. Okay? So that said, correlation coefficient questions are such a common Regents question. It is a procedural question. It is a calculator question. You do need to know how to do this. So we are going to go through this and show how I do it in a way that releases a little bit of mental stress and clears the mind a little bit, because when you're typing and checking and typing and checking so much, it kind of clutters your brain for this question and future questions. So let's actually read the question. Number 31, the owner of an ice cream stand kept track of the number of ice cream cones that were sold each day of the first week in June. She compared the ice cream sales to the average daily temperature. The data are shown in the table below, and I do read the table. Average daily temperature, 72, 75, 81, 78, 77, 76, 80. And daily ice cream cone sales, 126, 183, 263, 229, 200, 185, 249. The question, state the linear regression equation for this data, rounding all your values to the nearest hundredth. This is where I'm going to show you, again, what I recommend for the muscle memory fixing strategy. First off, we need diagnostics on. That's in the catalog in blue. Some of you have that in your mode, and you could literally turn on stat diagnostics on in your mode, but not everyone has that. So I'm going to go to my blue catalog, and I'm going to scroll down slowly, scroll to diagnostic on. Diagnostic on. That might take you longer than I just took. Press enter and then press enter again. Diagnostics on is done. Okay. Now, how do I make the linear regression equation? I go stat and edit. List 1 is the x coordinates. I'm just going to clear these. Clear this because I don't want to cause confusion here. Clear this because this is how your calculator will probably appear. Do you not need to know how to do the diagnostics on? Yes, because your teacher or your school may not turn diagnostics on for you. So you need to know how to do diagnostics on. Again, it's in the catalog. You scroll all the way to diagnostics on, press enter twice. Now, your x coordinates are your L1. So I'm not going to check my answers while I'm typing, believe it or not. I'm going to check my answers after typing. 72, 75, 81, 78, 77, 76, and 80. Okay. Why do I check after? Because it takes a lot of brain power and it causes you to become slower if you check while you type. If you type first and then check, you do better. 72, 75, 81, 78, 77, 76, 80. And then the next one, I'm going to type and then check. 126, 183, 263, 229, 200, 185, 249. Okay, now I check my typing. 249, 185, 200, 229, 263, 183, 126. Great. I did a great job. Okay. How do I now get the line? I go to Stat, Calc, Lin Reg AX plus B. That's linear regression in the form AX plus B. Press Enter. I'm going to do L. If there's nothing entered here, it should be L1. If something else is entered here and you need L1, L1 is in blue above the 1 button. So I press the second button and press L1, although that normally is typed in for you. Same thing here. L2 is above the 2 button in blue, so I press the blue second button and L2, although L2 is normally typed for you. Frequency list, there is no frequency list. Store the regression equation. I do store the regression equation. How do I store it? Vars, y vars, function, and I'm going to store it as y8. I think that one's still not used. Enter, enter, and then calculate. And now this is the muscle memory fixing strategy, because I see a lot of students get points off by just not typing the correct number of decimal places. Really just that. So how do I do this? They told me what A and B are, so I know that Y is equal to, with all the numbers, I do put all the decimal points again, 15.125x minus 959.625, and then I look to the nearest hundredth and I round as my step 2. So I write all the decimal places and then I round. Y equals 15.13x minus 959.63. That's my answer. Okay? That's 2 points. The next one, state the correlation coefficient to the nearest hundredth. Again, I do the same thing. I write the full number. R equals 0.99170809888. And then I look where they told me to round, and I round to what they said, 0.99. Okay? And that's another point. And then finally, state what this correlation coefficient indicates about the linear fit. Now, what this represents is a strong positive correlation. Strong positive correlation. They don't want any more than information than that. So why is it strong? Because R is really close to 1. Positive because R is greater than 0. That's all they want. So, but what does that mean? What does that mean? And it does matter what it means on the Regents, because they could give this as a part 1, right? So I'm going to graph. I'm going to turn off 7. It looks like I probably did have something as 8, but now I have the linear regression equation. Notice I didn't type that. I didn't type the linear regression equation, the 15.125. It's typed for me. Why did I type it? Oh, why is it typed for me? Because I stored it. That's what the store reg equation does. If you want to review how to do this problem, I highly recommend rewatching this exact problem, because it's 4 points every single Regents. And remember, if you're playing a game of points, you are not playing a game of 0 to 85. You are literally playing a game of plus or minus 4. If you're just like passing sometimes and not passing sometimes, if you just learn how to do this one problem, you just passed. If you are trying to get an 80, but you're always close to an 80, and you learn how to do this problem, you just got an 80. If you're trying to get a 90 and you just learn, but you're close, but you just learn how to do this problem, you just got a 90. And of course, if you're trying to get 100, you just have to know how to do this question. Okay, so I'm going to turn on plot 1, stat plot 1, 2 on. I'm going to graph it, zoom, and I'm going to do zoom stat. And you see that line? That line is really close to those points. That's what a strong correlation means. Now, notice that the slope is a positive slope. That matches the sign of the R. Notice the slope is positive. So R is greater than 0, but you can also say that M is greater than 0. So worth noting that. Okay. If R was far from 1, like let's say 0.7, the points would be farther from the line. If R was negative 0.99, the slope would be negative. If R was like negative 0.3, the line would be a negative slope and the points would be pretty far from the line. And if R was like close to 0, I mean, the points would be so scattered, who knows where the line would be. Okay. Número 32, number 32. Graph the system of inequalities on the set of axes below. Y is greater than 3x minus 4, and x plus 2y is less than or equal to 6. And this one says to label the solution set S. If you don't label the solution set S, you lose a point. Okay. So I'm going to graph the second one first, because of the straight edge situation. So the second one, x plus 2y is less than or equal to 6. I like y equals, or y inequality, mx plus b. So I'm going to solve for y. Although there are ways to graph from this point. Get 2y is less than or equal to negative x plus 6. Divide by 2, divide by 2. Y. Now, I divided by a positive 2, so the inequality does not change direction. Y is less than or equal to negative 1/2 x plus 6 over 2 is 3. Okay? So I have a slope of negative 1/2. I'm going to plot the y-intercept, go down 1 over 2, 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 and then up 1 over negative 2, 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 up 1 over negative 2. I got my line. Now this is not a strict inequality. It's less than or equal, which means the line is part of the solution set. So I'm going to graph a straight line. Notice that my software graphs perfectly straight lines. Am I required to use a straight edge? Yes, you have to use a straight edge to graph this line. I'm going to graph the arrows on top. And now, do I graph to the left, to the right? Do I shade to the left, to the right, above or below the line? Notice that below and to the left of the line are the same region, and above and to the right of the line are the same region. There's one interpretation that is better than the rest. If you get it to y inequality mx plus b symbol, a y inequality symbol mx plus b, it's shading above or shading below. Since y is less than or equal to this line, y is less than or equal to negative 1/2 x plus 3, I shade below. So this is a shading below. Okay. So I'm going to shade all of this below. You don't have to shade by like scratching it out. This is a great way to shade. In fact, it's a useful way to shade because you could see the intersection of multiple regions. Now, why did I want to do that one first? It's a software issue. You are not working with software. You are working with pen and straight edge. I'm working with software, which means I'm not working with a straight edge. So this, you're going to have to remember that this inequality also has to be graphed with a straight edge, even though because I'm working with software, I can't use a straight edge to graph this one because I don't have one. So y is greater than 3x minus 4. Now, you might say, well, I just graphed this straight line with a straight edge. Well, actually, let me see if I could actually do some cleverness here. Let me see. I don't see any option to turn this into a dotted line. Yeah, I did work in a software the other day where I was able to convert lines into dotted lines, but that's not this. Okay, so what it means is I have to create this red line, but I don't have a straight edge. You are required to use a straight edge, and you're just gonna have to remember that. So y-intercept -4, slope -3, slope +3, so up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. So it's like here-ish. Down 3 over -1, down 3 over -1. And now I have to do without a straight edge because I don't have a straight edge, but you are required to use a straight edge. Okay? You are required to use a straight edge for the thing that I didn't do a straight edge. Now, why did I use a dotted line? Because this is a greater than without an equal sign. Okay? Dotted line. Because of the not equal. And this is a solid line because of the equal. Okay? So I graph that line. And so this is the place where you want to think about above, below, left, or right. You actually don't want to interpret it as left or right at all. You want to interpret it as above or below. Y is greater than 3x minus 4. That means y is above the line y equals 3x minus 4. So we're going to shade above the line. So we got the line going like this. We're going to shade above it. Okay? So let's make those straight lines. And we see a region that is shaded twice. Okay? And I have to make a big in this region. Okay? Some students do literally this to make it more visible. And some students just write the S. Okay? This can be graphed in pencil. Graphs can be done in pencil. How do I know this is the region? Because this is the only region that is in both intersection points. Now, the next question, is the point 2, 2 a solution to the system? That's this point here, 2, 2. Now, you notice that it's in the intersection of those two lines. So it is a boundary point. But one of the lines is a solid line. So that point 2, 2 is in the solution set for the one bounded by a solid line, but it's not part of the solution set for the one bounded by the dotted line. Now you might say, why not? Just because it's a dotted line? No, the dotted line represents that that line is not in the solution set. That's literally what the dotted line represents. Y greater than 3x minus 4, so y is not equal to 3x minus 4. So points on the dotted line are not part of the solution set. So no, because points on the dotted line are not in the solution set to y greater than 3x minus 4. That's it. Okay. 4 points. 4 points. And we are 14 points away from a perfect grade on this Regents. 14 points away from a perfect grade on this Regents. Número 33, number 33. An object is launched upward at 64 feet per second from a platform 80 feet above the ground. The function s of t models the height of the object t in t seconds after launch. If s of t equals negative 16t squared plus 64t plus 80, state the vertex of s of t and explain in details what each coordinate means in the context of the problem. So I'm gonna make the platform. I'm actually gonna draw this out. What just happened? I'm gonna make the platform. Okay. And I'm gonna see. I don't like where I drew that. Okay. Very software. And I'm gonna draw the path of the object. So the path of the object goes like this, up, gets to a peak. Okay. Let's try it again. Goes up, gets to a peak, and then comes back down. Now, I don't know if it's going to fall off the side, but it does get to a peak. Okay. So I don't, because I haven't read the rest of the problem, at least in theory. I can read it right now. After the object is launched, how many seconds does it take for the object to hit the ground? Okay. So this is 80 feet above the ground. Okay. So this is 80 feet above the ground. State the vertex of S. Okay. So the vertex, this is a worthwhile formula. In standard form, AT squared. Okay. AT squared plus BT plus C. The vertex is at H is equal to negative B over 2A, which is equal to negative 64 over 2 times negative 16. And again, I could do negative 64 over negative 32 equals 2 in my head. But if you didn't know that, again, let the calculator do your arithmetic. Let me quit. Negative 64 divided by parentheses for the numerator, for the denominator rather, divided by divided by 2 parentheses, actually 2 times negative 16, close parentheses, and that confirms that it's a 2. Okay, and then the y-coordinate of the vertex, k, is equal to s of h, which is equal to s of 2, which is equal to negative 16 times 2 squared plus 64 times 2 plus 80. And I can, again, let my calculator do the work. It is worth, there's a clever, if you're just comfortable with arithmetic, if you do it in parts, negative 16 times 2 squared, you get negative 64. If you found the vertex correctly, or the x-coordinate of the vertex correctly, the second number that you add is always going to make the answer the opposite of the first number. 64 times 2. So we got a negative 64 a second ago. We should get a positive 64. We do get that. So it's just a mental trick that I learned in the past. And then plus 80 equals 144. So the vertex is equal to 2 comma 144. Okay? And it does ask us to explain okay. Let me move this, yes. To explain in detail what each coordinate means. In the context of the problem, this requires words. Okay, So what does the vertex mean in the context of the problem? Well, at 2, and now this move 2. This is what happens when I try to move something after the fact, but I should have watched for the location of those words, right? Means, so what this means is that it takes 2 seconds for the object to reach the maximum height, and that maximum height is 144 feet above the ground. That's what it means. So at time t equals 2 seconds, the object reaches a maximum v height of 144 feet above the ground. And that's 2 points. Now the second part, after the object is launched, how many seconds does it take for the object to hit the ground? So the ground is all the way down here. So we do have to track and continue on to the ground, okay? At 0 feet, okay? And justify your answer. Now justify, this is algebra. Algebra is good enough. Now I do like to make an estimate. I've always told my students that if it takes it 2 seconds, 2 seconds to the peak, plus then it takes another 2 seconds to back to where it started, plus really fast to the ground. Why is it fast to the ground? Well, because as it's falling, it's actually accelerating, so it's getting faster and faster and faster. Which means I'm going to say plus approximately 1 second more. So 5 seconds total. That's my estimate. Let's see how good my estimate is. So, but S of 0 is the bottom position, and this is equal to negative 16 t times 0. I'm sorry, so I misspoke. S of t is equal to 0. That's what we're looking for. S of t is equal to 0 because height is 0. That's equal to negative 16t squared plus 64t plus 80. Okay. Now, we got lucky here that we don't have to worry about the quadratic formula, although we could use the quadratic formula. We are allowed to use the quadratic formula here. But it happens to be that we could factor out a negative 16. And this is how I did it. Parentheses t squared minus 4t minus 5. And it's convenient because this is factorable over the integers. Blank plus blank equals b equals negative 4. Blank times blank equals c equals negative 5. And in fact, negative 1 times positive 1. Positive 1 times negative 5 equals negative 5, and positive 1 plus negative 5 equals negative 4. And so this factors as, so 0 equals negative 16 times x plus, not x, t plus 1, t minus 5, and I solve. Do you have to do negative 16 equals 0? No. But might as well recognize that I'm doing the zero product property. Now I do t plus 1 equals 0. Minus 1 minus 1. I get that t equals negative 1. But I reject this one because in this scenario, because t is less than 0 doesn't fit the situation. Okay, I want to be clear. There's nothing wrong with t being -1 algebraically. There is something wrong with t being -1 physically. This scenario started at time t equals 0. The object was launched to the ground. At time t equals -1, there was just some waiting happening. This model doesn't fit time t equals -1. The object hadn't been launched yet. So the launch function doesn't work. Now t minus 5 equals 0 plus 5 plus 5. And look at my estimate. My estimate was 5 seconds, and I got t equals exactly 5 seconds. Now, do I have to give the units seconds? No. They gave the units. This is an important lesson here. If they give the units, you don't have to give the units. If they don't give the units, you do have to give the units. Fun fact, though, they'll basically always give you the units. Basically always. Not always, not guaranteed, so you have to look for it. And sometimes you have to change units, and you have to look for that. So just the number 5 is a solution. Okay? How do I see that? How do I know they gave us the units? Because they said how many seconds. All right. We are 10 points away from a perfect grade on this test and 2 problems away from a perfect grade on this test. Número 34, solve 34. Solve the system of equations algebraically for all values of x and y. Algebraically for all values of x and y. Y equals x squared plus 4x minus 1 and y equals 2x plus 7. It helps to not do it algebraically for the purposes of getting all your points. I'm going to scroll all the way down to, I got to plot. Undo this plot. Scroll all the way to 9 and 10. Undo this graph. Or you could delete, graph 1 and 2. But I like to preserve all of my graphs if possible, so I could check my answers out to the test more easily. So x squared plus 4x minus 1 and y equals 2x plus 7. So I'm going to do zoom standard. I got a nice parabola. And now I got a line. And unfortunately, the intersection point is above the graph. So if I wanted to get an estimate for the second point, I need to do something like zoom fit. And zoom fit will fit both graphs perfectly in the screen. I'm gonna speed up the calculator. Okay. Now, but for the purposes of trying a number out, I'm going to calculate the location of that intersection. So the calc is in blue on top, so I press the blue second button and calc. Intersect is 5. The first curve, enter. Second curve, enter. I'm going to guess, I'm going to get as close as possible to that intersection as I can. Sure. Press enter. And I get an integer point. When I was looking at it, although I have the answers here, I do have the work here. Can you see it? Visually speaking, I do. I just didn't expect it to be an integer for some reason. Maybe because the zooming didn't let me see it. Okay, but why am I doing it on graph paper? Because if you just write 2 and 11 and do the same thing for the other point, and this point is -4, -1, that's a point. You do get 1 point for just giving the numerical answer, but that's only a point out of 4. But if you're playing a game of points, remember it's plus or minus 4 in your case. If you're playing a game of points, you just got a point, right? Out of 4. Now you need to just scrounge up 3 other points in places that you're not used to getting them from by showing work. And if you show work, you could actually get way more than 4 points. You can get 20 points easily. But how do I do this algebraically? Algebraically, I know that y is equal to the first expression, y equals the second expression. So I could set those 2 expressions equal to each other. So 2x plus 7 equals x squared plus 4x minus 1. And now I do algebra, subtract 2x, subtract 2x. I could also subtract the 7 right away. So I'm going to do that. I got 0 equals x squared plus 2x minus 8. Now, the quadratic formula is a valid algebraic solution. There was a point where there was an argument about whether the quadratic formula is numerical or algebraic. They do qualify that as an algebraic solution. Okay, but I'm not going to do the quadratic formula because I don't need to. A equals 1. That checks. So b equals 2 and c equals -8. And it happens to be this one factors over the integers. It doesn't always factor over the integers, even when a equals 1. Like, for example, the other one that was like 3 plus or minus radical 33 over 2 or something like that. That one didn't factor over the integers, so this wouldn't have technically worked unless you were clever. Blank plus blank equals 2, and blank times blank equals -8. Factor in with an 8, 1 and 8, 2 and 4. 3 does not divide 8. 4 is on the list, so I have my full list. And if I do a 4 and a -2, a 4 and a -2, 4 plus -2 is 2, and 4 times -2 is -8. Great. So I have 0 equals x plus 4, x minus 2. And I get x plus 4 equals 0, minus 4. I get x equals -4. And if I do x minus 2 equals 0 plus 2 plus 2, I get x equals 2. A lot of students stop here. And for this, they get 3 points out of 4. Why don't they get 4 out of 4 points? This one is not like an f of x and a g of x. This is a y equals something of x and y equals something else of x. You need the y coordinates. That's why. So if I plug in x equals 4, I could do y equals 2 times -4 plus 7. Let my calculator do this. Plug it into the calculator, I get 1. And I plug in x equals 2. Y equals 2 times 2 plus 7. Equals 11. And I get the point here, -4, comma 1. And I get the point here, 2, comma 11. And I could check my answer by plugging into the first equation. You know, -4 squared in parentheses plus 4 times 4 minus 1 is 1. Sorry. Look at me making an arithmetic error because I didn't use my calculator. You see that? If I'm capable of making an arithmetic error, then you're capable of making an arithmetic error, right? So I made an arithmetic error. So let your calculator do the arithmetic for you. Especially if you're like me right now, you hear my voice, you see my eyes closing a little bit. Maybe I'm feeling a little tired. That happens. That happens for you on a test. It happens to be I'm drinking decaf. I told you that I'm drinking coffee, but I'm drinking decaf for hydration. Unfortunately, it's like 11:33 p.m. for me. I'm doing this for you, so it's worth my time to do this, even though it's 11:30 p.m. But it does affect my ability sometimes to miss a minus sign. And I am a person who loses negative signs, which is, by the way, an error that is common to almost every high school kid. So those are my answers. I plug into the original. Good thing I checked my answer because I would have told you that the answer was 1. I checked my answer for 16 minus 16 minus, or 16 minus 16 minus 1 is -1. And I was like, wait. But I got it right. And this one, 2, I got 2 plus 8 is 10 minus 2 plus 2 squared is 4 plus 8 is 12 minus 1 is 11. So these are correct. Plug into both equations. Notice that they didn't require you to check. I wish that at some point in the future, they actually force students to check at least one question. Okay? Very last question. Very last question. We actually made it. If you made it to this question, congratulations. I want to thank you for being here and being here with me. This is definitely a worthwhile thing for me. I hope that this has helped you. A correct credit here will answer here will receive 6 credits. Got to show work though. Here, number 36, number 35, Jen joined the fan favorite movie club at a local movie theater. At this theater, the cost of admission in May and June remains the same. In May, she saw 2 matinees and 3 regular price shows and spent $38.50. And in June, she went to 6 matinees and 1 regular price show and spent $47.50. Okay. Write a system of equations to represent the cost M of a matinee ticket and the cost R of a regular price ticket. Okay, so this is where I want you to think of how algebra works. And I'm gonna just do some quick notes for the students who really struggle with this kind of question. So one ticket costs M. Okay, M is the variable here, the cost of a matinee ticket. Now, 2 matinees cost M plus M is 2M. 3 matinees cost 3M. 4 matinees cost 4M. And so the number of matinees, the cost, so all matinees, all the matinees cost, and then is equal to the number of matinees, times the cost of one matinee. I'm going to put mat for matinee. So that's how to get the cost of all the matinees put together. So that tells me how to put these letters and these numbers together. So what do I need to do to create the equation? So the cost of all matinees plus the cost of all regular priced shows, okay, equals, and I'm going to change to blue because I'm running out of space, the cost, the total cost. That is the format that all of my equations are going to take. So the cost of all matinees in May, she saw 2 matinees, which each cost M dollars, that's 2M, plus the cost of all regular price shows. She saw in May 3 regular price shows, and each one cost R, and that's equal to the total cost in May, $38.50. And then in June, she went to 6 matinees, so the cost of all the matinees is 6 times M, 6 times the cost of one matinee, plus the one regular price show times the cost of one regular price show. That's equal to the total cost, $47.50. And there's 2 points. Okay. The second part. Jen said she spent $5.75 on each matinee and $9 on each regular show. Is Jen correct? Justify your answer. Only arithmetic is required, but you do have to say at some point, yes, she's correct, or no, she's not correct. But you don't have to give a verbal explanation why. You can give an algebraic explanation why. And so how do we check this? We have our equations. So we could plug in into our equations. Now, let's talk partial credit. Suppose you didn't know how to do step 1, so you got some incorrect equations. But you want to check if she's right about her costs on the second part. You could still plug into your possibly incorrect equations and get full credit for the second part. You won't get credit for the equations, but you'll get credit for checking if she's correct. So that's what we're going to do. We're going to plug into the equations. I'm going to plug into the first equation. So let's see. 2 times, maybe she spent $5.75 plus 3 times, maybe she spent $9 on the matinee, the regular price shows. This is going to be, is this equal to $38.50? This is gonna end in 50 cents. So I'm gonna let the calculator do the arithmetic. Right? We talked about that. Let the calculator do the arithmetic for you. 2 parentheses 575. But do you need to write what I wrote? Yeah, you do need to write what I wrote. You just don't have to do all the arithmetic on paper. 3 times 9. And yeah, that's 1150 plus 27. But it's 3850. So that's correct so far. So maybe she is right. But let's try the second equation. 6 matinees at $5.75 plus 1 matinee at the regular price at supposedly $9. This is equal to $47.50. Okay? This does end in a 50-cent mark again. So I can't just quickly know that I'm wrong or right. So now I have to do, nope, that's not what I'm trying to do. There we go. Move that down. I'm trying to plug in into the calculator, and I'm not going to simulate this plugging in. Oops. Meant to click on something incorrect. I'm not going to simulate plugging in this time because you could plug into the calculator. But the left side actually equals 4350, and that's equal to 4750. This is definitely not. This is false. So she is not correct. And I will say this, every bit of graveliness that I have in my voice right now is definitely worth it because my goal is to get you the best grade possible. I always have wanted to have a free arm of my tutoring business, no matter how much I charge for tutoring. If you do want to know how much I charge for tutoring, if you're interested in tutoring or if your parents are interested in tutoring, go to JuanTutors.com and check it out. I tutor there. I have tutors who work for me in math, in English, in history, even in computer science and art. So if you're interested in any of those subjects, definitely check it out. Um, but in the meantime, I'm really excited to have you here. If you feel that I've earned the subscription, and I think if you reached this point in the video, I think I have earned your subscription. That's how I earn my little bit of money on these videos. So please do, I appreciate it if you just click the subscribe button. And if you have any comments, like any thank yous, leave them in the comments because those also motivate me. If you have any questions at all for any part of the video, please do ask the questions. And if you're wondering what to do at this point, if there's any questions that you got wrong, re-watch those questions and until you get them right, without my help. Okay? Or another option is I have done other Algebra 1 videos. You could go to another Algebra 1 video and watch that as well. But in the meantime, I do appreciate it. If you think I ought to subscribe, thank you. I'm just going to finish the last problem. I'm literally going to mic drop and call it quits. All right? Congratulations for making it here. We are 2 points away from a perfect grade. Use your system of equations to algebraically determine both the actual cost of each matinee ticket and the actual cost of each regular price ticket. So we have 2m plus 3r equals 38.50. And we have 6m plus 1r is equal to 47.50. So I did this on my paper by elimination, the elimination method. Now, why I multiplied the first equation by 3 to eliminate the m, I don't know, but that's what I did. So if you multiply, because you could also multiply the second equation by 3 and eliminate the r. Honestly, either one is fine. So I'm going to multiply this by -3, and I got that negative 6m minus 9r equals negative 115.50. Did I do that arithmetic in my head? No, I did not. I let my calculator do that. Okay. And now I can add these two equations together and they cancel out the m's. I get 0m minus 8r equals negative 68. So m is gone. So that negative 8r is equal to negative 68. I divide by negative 8, divide by negative 8. And I get that r is equal to $8.50. They don't care that you wrote it in dollars. They said they gave the units cost. Okay. So you don't have to give the units. Okay. Then now that I have R, so I did, the first thing is I eliminated a variable. The second thing I'm going to do is I'm gonna do this in blue. I'm gonna use that variable, solved variable, not use that variable. Use the solved variable to get the other variable. To get the other variable. And before I do that, I did have a question for you. Let me know. This video is in vertical format, and my other Algebra 1 video is in horizontal format. Actually, let me know which one you prefer. Because if you prefer the vertical format because you feel like it's better organized, I'll do the vertical format. But if you think that the horizontal format is better, I'll just do the horizontal format. Okay? So at this point, I'm going to get this variable. Again, I'm going to pick up the mic, going to drop it. I'm going to say congratulations. Thank you for being here with me. I really appreciate your effort for having made it all the way through. I'm going to plug in r equals 8.5 into any one of these equations. I got 6m plus 1 times 8.5 equals 4750. I do have to do the algebra. So 6m plus 8.5 equals 4750. Subtract 8.5, subtract 8.5. Yes, I can do the algebra in my head, of course, the arithmetic in my head. 6m equals, but I do this on the calculator. 47.5 minus 8.5. 0.5 minus 0.5 is 0. 47 minus 8 is 39. But I do that on my calculator. Let the calculator do the arithmetic. Divide by 6, divide by 6. We're about to do the mic drop. We're about to get 100 on this test. Ready? M equals 6.5. Circle that. Circle that. Pick up the mic. Drop it. Congratulations. We're done.